All right, looks like we are live. Welcome, everybody, to Standing for Truth. My name is Donny, and I am your host and moderator for tonight's round two debate, the much anticipated rematch between Jamie from Studio 215 Official and Taylor from the Snake Was Right YouTube channels. And tonight we are debating single to multi-cell evolution. It's a technical topic, but it is an important topic. Both Taylor and Jamie, they've done just a ton of study on this topic that has been discussed on and off, I would say, for the last 3 or 4 years. So I'm really looking forward to this. I know the audience is as well. And so before we get into any of the opening statements and the debate itself, let's have some brief introductions with our debaters, a way to get acquainted. Jamie, why don't we start with you? A little bit about yourself for anybody who might not be familiar with who you are, and also a little bit about your channel, Studio 215.
Yeah, so I run the YouTube channel Studio 215 Official. We do Bible studies. We do a different video series on evolution, creation, all of that good stuff. During one of my debates last week, someone mentioned something about rap battling. So just to have fun, I made a little rap song, I guess, and people seem to think that's pretty funny. So a lot of different variety on my channel, but we got a lot of projects in the works. So the longer the channel is up and running, the more stuff you will see on that channel.
Very cool, Jamie. You've done several debates at this point, so you're no stranger to debates. And Snake, of course, you're no stranger. You're seasoned, you're experienced. And so this will definitely be a debate to remember. And both of your links to your YouTube channels are in the description box for people to check out. Taylor, let's hand it over to you. Brief intro. How you doing today? A little bit about yourself and a little bit about your channels.
Oh, not bad. Yeah, so I run two channels, Snake Was Right and Debate Cafe. I run the latter with my best friend and co-host, who is a debate coach, and we're having a debate next Sunday, I think, with Jill, Jesus is Lord, on what the topic is: does the Bible advocate slavery? And but for my personal channel, I do a lot of debates there too, but mostly theological topics, but pretty much anything I'm interested in. I like to debunk things, but I try and take a source methods angle and a skeptical angle. And so I've landed myself in opposition to a lot of the atheist community that I'm a part of as well. I'm, arguing against communism, against moral relativism, but I do also argue against theism and creationism, stuff like that. So broad range of topics, and probably not your typical set of priorities. And yeah.
Well, you've got a nice solid mix of topics over on your channel, a little bit of anti-communism. That sounds fun. And so I appreciate that. Looking forward to your upcoming debate with Jill. So for anybody in the chat that are debate addicts, like probably all of us here on the panel, please do check out both of our guests' channels. So I appreciate the intros. Gentlemen, let me go through the format for tonight a little bit. We're going to be having 12-minute opening statements, followed by 8-minute rebuttals. And then we're going to have a roughly 50-minute back and forth discussion on the topic. We'll keep it more free-flowing. Then we'll have a 5-minute closing statement. Jamie and Taylor can wrap up their thoughts and points for the debate. And then this is where we get you guys in the audience involved. We'll have about a 25-minute audience Q&A. Let's try and keep it on topic as much as possible. And just make sure you're tagging me either at Donny or at Standing for Truth, and that way I won't miss it. Okay, so with that, we are going to get right into the opening statements. And from my understanding, Taylor, are you kicking us off, or was it Jamie? Oh, I think you're muted.
Yeah, I thought maybe Jamie would go first, since this is kind of like a response to the first debate, but whatever works best.
Sounds good to me. Jamie, we're going to hand it over to you. If you're ready, you've got 12 minutes. Floor is yours.
Yeah. All right. So I have a PowerPoint presentation, but I kind of went through the entire PowerPoint last week when we did our video. So I'm sure he's going to talk about some of my talking points from that. But instead of going through the same PowerPoint, what I would really like to do is I would actually like to just go through the peer-reviewed paper itself and just kind of dissect what they're saying and how they add the evolutionary assumption onto it, but they never actually admit that this is a multicellular evolution. So that's what we're going to do. We're just going to go through the paper word by word for about 12 minutes. We probably won't make it through all of it, but I feel like this will probably be the most beneficial for the people watching. So I'm going to go ahead and full screen the paper now. All right, so if I have to, I'll turn off my camera, but it looks like we might be able to just go through this paper without it. One of the biggest arguments that I hear is that creationists are always quote mining. So I wanted to show you guys that this is not quote mining, okay? If we look at this paper, I read through the entire paper and made lots of notes, okay? So yeah, this is not quote mining. I read through this entire paper, and when I summarize something, that's just me trying to prevent having to read the entire thing. So let's go ahead and go from the beginning and just see what this paper actually says, since this is the one that Taylor likes to focus on most of the time. The transition to multicellularity. So keep in mind, multicellularity, they're going to say this a lot, but then they're going to backtrack and say that it's clusters. The transition to multicellularity enabled the evolution of large, complex organisms, but early steps in this transition remain poorly understood. So they're always going to start with this assumption that evolution happened. So now we have to prove it. This already shows that they're wanting a specific result. They're not letting the data speak for itself. They have an assumption built into the data. So moving on from the first sentence, it says, here we show that multicellular complexity, including development from a single cell, can evolve rapidly in a unicellular organism that has never had a multicellular ancestor. So again, they're saying this can evolve, and here's how we try to do it. But what's interesting is multicellular complexity sounds, it sounds like it's a single cell turning into a multicellular organism. But in fact, multicellular complexity is the diversity of specialized cell types. And this usually is measured by the number of cell types and total numbers of cells. But what's important about that is the part of the definition that says it's the diversity of specialized cell types. If y'all watched my presentation that we played last week, there is no specialized cell types. What we see is that some of the cells lose the function of being germline, and some of the cells lose the function of being motile. So they all had the functions from the beginning, but then as they were artificially manipulated in the lab, some of them lost these functions and some of them lost other functions. So that's what they're saying when they are talking about multicellular complexity, is that this is considered diversity, but it's not considered diversity because this isn't specialized functions. It's nothing new. And if you really want to, go over the technicalities of that, I can pull up the PowerPoint where I explain the difference between specialized cell types and what they showed in this demonstration of the paper. But we'll save that for the open discussion more than likely. The next sentence in this paper says, we subject the algae Chlamydomonas reinhardti to conditions that favor multicellularity. So right here, they're telling you that they used intelligent input to artificially manipulate this Chlamydomonas to do something that they wanted it to do. So they knew it had this feature inside of its DNA, and now they're just trying to express that in a larger scale. Next says, resulting in the evolution of a multicellular life cycle in which clusters, keep in mind this is clusters, reproduce via motile unicellular propagules. Now, one thing I want to point out is this phrase multicellular life cycle, because what this means is the growth of a propagule into a colony and its fragmentation to give rise to new propagules. I'm reading definitions that I wrote down specifically so I can give you the exact definition as we go through this paper. So a multicellular life cycle does not mean that it is a multicellular organism. It means that there is a stage of its life cycle where it creates a colony and uses that colony as part of its reproductive process moving forward. So again, this is not a multicellular organism. A multicellular life cycle is just manipulating what was already there to create a life cycle that uses a colony or a cluster. Now, I'm not going to read through every single word, but there's a couple of things that I highlighted, and that's what I kind of want to focus on here. However, if you really want to read the entire paper, we can do a whole word by word, sentence by sentence breakthrough of this. But moving down to the big T that you see on the left-hand side, the transition to multicellularity was one of a few major events in life's history that created new opportunities for more complex biological systems to evolve. I should have put that in red because you'll notice that I have different colors here, and everything that's red is an evolutionary assumption. So this is them putting the assumption of evolution onto what they're experimenting with. So here they say this transition happened, so now we have to prove it. In the next sentence, it says, as this transition fundamentally changes what constitutes an individual, dissecting the steps in this transition remains a major challenge within evolutionary biology. So what they're saying in this paper is that this is a major step that they have to figure out in order to have a full theory. And what you'll find throughout this paper is they didn't figure it out. What they did is they artificially manipulated this Chlamydomonas to create clusters naturally or obligately, as Taylor will say. But still, at the end of the day, it still wants to be single cell. At the end of all of these experiments, the cells try to separate out. And what happens is when some of them try to separate from the cluster, they actually die, which shows that they have lost function to the point where they become dependent on, similar to the Amish survive with one family by themselves out in the wilderness, I guess you would say. They have their own farm. An Amish family can run the entire farm by themselves. But as soon as they adapt to a city lifestyle, they will become dependent on other sources. And once they become dependent on those other sources, they may lose the skills that they already had when they were independent. And now they are dependent on the extra sources for all the other things that they lost the skills in. Moving on, you see this big block of red, and this is essentially them putting this evolution concept onto the work before they even start demonstrating it. It says, compared with other major transitions in evolution that occurred just once, like the origin of eukaryotes, which they also have never been able to prove that. And there's actually something I want to point out about this because you can't really see it in the screenshot, but they'll say something like this. They'll say, just like, for example, the origin of eukaryotes, and they'll reference a paper. So you'll see a little number in the corner. And when you go to that number at the bottom of the peer-reviewed paper, it takes you to another paper. Most of the times when they make those references and you go and look at the other papers, they don't prove anything either. They're also making assumptions. That was one of the best things that I learned when I was watching James Tour, was he shows you how to take the references and break down the references, because as you go down these rabbit trails, you'll find that they never really prove anything. It's always assumptions, but then they reference other assumptions from other papers. So it's very deceptive the way that this peer review process is being put together. Next, it says multicellularity has evolved repeatedly. That's not true. We have not seen multicellularity evolve, not even in this experiment, as we're about to see. I'm going to try and skip through some of this so that we can really get to the meat of it. It says most origins of multicellularity are ancient and transitional forms that have been lost to extinction. So after they give this whole evolutionary explanation for multicellularity coming from single cell organisms, they say, yeah, but all the transitionals, they actually died off from extinction. And I would say, how convenient is that? That there's thousands of species out there, maybe hundreds of thousands of species. I don't know the exact number, but of every single one of these species, all of the multicellular transitional forms have gone extinct. I think that's extremely convenient for their position. So little is known about the potential for multicellularity to evolve from unicellular lineages. So this is essentially them CYA, covering their butts. They're saying that, this did happen, but all the transitional forms are gone. So, don't even try and look into that, because we would argue as creationists that they never existed in the first place. And they know that they can't show these transitionals, so they have to come up with an excuse. And this is the excuse that they come up with, that they've all died off. So moving on, let's go ahead and go down here a little bit. Okay. So it says here we use experimental evolution. Now, this is an interesting phrase, and experimental evolution, by definition, is the use of a laboratory or controlled field manipulation, which would also be known as intelligent input, to investigate evolutionary processes. So what they're saying is, we're using intelligent input to prove that intelligent input doesn't exist, right? They don't want to believe there's a creator, but they want to create things and then say that they could have evolved by themselves. So, I mean, that's kind of backtracking on their own reports. That's kind of how Kent Hovind always says, you know, if they were able to create life in the lab, that would mean that you need a creator to create life, right? Because it's not happening on its own. And they'll actually admit to this later on in the paper if we get to the bottom. So that's why I'm going to try and speed through as much of this as I can. Next, if you look at the yellow under the red highlighted section, the yellow highlighted section on the right-hand side, it says, a hallmark feature of complex multicellularity is a two-stage life cycle in which multicellular individuals develop from a single cell. Now, complex multicellularity, this was an interesting one because what I've learned is that if you hear them reference complex multicellularity, it's actually different than when they say multicellular complexity. And I thought that was very interesting. Complex multicellularity is a two-stage life cycle in which multicellular individuals develop from a single cell with three-dimensional tissue organization and, according to the definition, a genetically predetermined developmental program. So that's coming from ScienceDirect.com. They are not a creationist source, and they say that this complex multicellularity is a visual representation of a genetically predetermined developmental program. That means it was created by a forward-thinking creator. Neither here nor there, though. This is just semantics on definitions, but let's go ahead and go through some more of this paper. The next highlighted part says, the ubiquity and persistence of the unicellular bottleneck has been attributed to the fact that it purges within-group genetic variation, eliminating the potential for among-cell evolutionary conflicts that might otherwise erode multicellular complexity. Then they give you if you look at the red over here, they try and give you a evolutionary interpretation for why that is. Because again, everything they're going to do in the lab, they're not going to be able to replicate in natural form in nature without some kind of intelligent input. So every time they make an assumption like this, they're going to have to backtrack it and say, but it doesn't happen in the wild because of, and then so on and so forth. Next, it says, this key trait may therefore catalyze the evolution of multicellular complexity. So the reason they're saying this is because of what they said in the red on the left-hand side. So let me actually read that first. What they said is instead...
1 minute.
Okay. So actually, let me go ahead and speed through all of this right quick. There's one part that I really wanted to get to down here on page 5. Oh, where's that page? Oh, that's page 3. Hold on 1 second. So since we have 1 minute, I want to just get to this part right here. So here it says, in our Chlamydomonas experiment, we observed the evolution of multicellular lineages, which they did not, that has a greatly increased rate of settling consistent with the selection regime. And then at the bottom, after they've given this entire evolutionary interpretation, what they say is, although it is possible that a controlled population could evolve multicellularity in a few months, this would be an unexpected outcome given that hundreds of independent lineages in the genus Chlamydomonas have failed to do so over hundreds of millions of years. So what they are saying in this quote is they're saying, we were able to get this Chlamydomonas to create a multicellular cluster for one of its life cycles, but you don't expect that out in the wild, because if that was as easy as what we made it in the lab, then we would actually have seen this at some point in time over the last hundreds of millions of years, right? So they're trying to cover their tracks because they say that they can do this in a matter of a few generations, which they can manipulate this and artificially select it to have these stages of clusters. But what's interesting is it always reverts back. And also, as easy as it was to do this in the lab, how can we never witness this in nature without someone manipulating it? That alone shows that the DNA is there to do it. However, under natural conditions, it will never do it, or else we would have observed it naturally. I'll go ahead and end with that. There was a lot of this article that I wanted to cover, but we just do not have the time. So what I'll do is I'll make a whole video just going through this sentence by sentence in the future.
Okay, Jamie, thank you for that opening statement, as this is a comprehensive topic. And I want this to be, especially because it is a round 2, I want this to be as thorough as possible. And we've been doing a lot of more hyper specific debates lately. And the goal is to make a lot of these debates and exchanges the go-to videos for people to check out, to kind of see a good representation of both sides and come to a conclusion. And so that was more so between 14 and 15 minutes. So I did give Jamie a couple extra minutes, which means Taylor, we are going to give you equal time, and you have between 14 and 15 minutes as well. Whenever you're ready, the floor is yours. Go ahead.
Okay, so last time we discussed why Chlamydomonas meets the criteria of multicellular evolution, and I'm glad to see Jamie finally cited a definition of multicellularity, since the one in his presentation was not, well, he actually didn't have one that was cited. It seemed like he made it up. But I have 4 different citations for the definition. You did say that they never say they're multicellular, but they do. And then you say this is contradicted by calling them clusters, and this is not a contradiction. Humans are clusters of cells. Calling them clusters is not the win that you think it is. They're clusters. It doesn't matter. What matters is whether they are clusters working as an individual or working as a bunch of single cells coming together. That are individuals themselves. So every multicellular organism is a cluster of cells. So yeah, I do have a slight advantage here. I saw your presentation. Hold on, I gotta plug something in. Hold on, sorry. Can I hit pause? My
Yes,
laptop's not charging.
No
I gotta
worries.
plug it in, or else it'll crash.
Paused right now. And so as you do that, to the audience, we are taking questions. Looks like about 3 or 4 have come in. And so they are all saved. Again, if you have questions, make sure you're tagging me, and we'll have a solid audience Q&A. As Snake continues doing that, Snake, you just let me know when you're ready. We will be back here Monday. Within a 7-day period, we've got about 5 shows. And so last night we had basically a 3-hour show with Mike. Oh, no worries, no worries. So last thing I'll say then, we'll be back here Monday, guys. Baptism debate, Jeremiah and Gavin. So Snake, now that you're good, floor is yours. I'll start your timer again.
Yeah, sorry about that. So where was I? This, it seemed like last time, like when your presentation, when you're giving it, seems like you said organs were necessary, that we could go over why this is not the case, since there are multicellular beings that you admitted are multicellular that do not have organs. So what you're kind of doing is trying to move the goalposts from simple multicellularity to complex multicellularity. You don't have to have organs systems or complex systems to be multicellular. There are multicellular algae like Volvox carteri. So this is simple multicellularity. But we should be talking about individuality. So this is something we went over last time. Functional organization of space was a contention. You didn't bring it up, I don't think, yet. So we'll just go over that real quick. So the extracellular matrix is, in fact, functional organization of space because it helps with movement and communication of these cells. It's part of the body. Other species exhibit specific cell body number type, cell bodies that have specific numbers. But these don't have cell differentiation, so it's like a more of a transitional. In addition to these other criteria, they have discrete bodies and cell differentiation of function. So these are differentiated cells working together as a single unit, a single individual, making similar individuals. Multiple papers identify that a multicellular individual contains cells that takes fitness hits for the good of the entire individual. This is what we see in the C. reinhardtii experiments. It's a higher level of coordination, a complex trait that single-celled aggregations do not possess, even those that cluster temporarily. So we're talking about cells that act as a single individual together with different responsibilities within the body or soma that gives rise to altruistic behaviors. These soma cells are sacrificing their ability to reproduce for the good of the whole body. This is caused by a gene that's present in the multicellular Volvox, which you admitted last time was truly multicellular, and C. reinhardtii has the same gene. And yet another paper that describes when selection acts on the whole collective rather than the individual cells, we do in fact have a multicellular individual by definition. So in these experiments, we do not see evolution of the individual cells. We see evolution of the whole cluster, which is an individual unit, individual cluster. So we see that many of the single cells in the body don't evolve or reproduce at all, as they contribute, but they contribute to the survival of the whole. The entire cluster is the parent. So, and they create children that become clusters no matter what. So these are clear, and there are clear physical boundaries in the body. They don't join with other clusters. And this paper, which helps define multicellularity, also mentions the genetic bottleneck effect that is another trait of multicellularity. Well, what do you know? C. reinhardtii evolves single-cell genetic bottlenecks, which means that the cells are no longer competing with each other, but in fact cooperating as a single unit, not just a bunch of the same units cooperating, as in the aggregations. And this results in fewer of them reproducing. They sacrifice themselves for their babies. And since they act as a single unit, a bottleneck occurs where a multicellular body produces single-celled offspring, which minimizes the ability for defects in the gametes and in the soma to survive. And it prevents most of the cells from competing genetically, opening them up to differentiation within the body. Most multicellular organisms reproduce with a single-cell bottleneck and reproduce with this unicellular and multicellular life cycle. You still seem to be having trouble understanding that this is the case. You said they fragment. This word does not appear anywhere in the paper. They don't. They send off single unicellular babies that grow up to become the exact same type of clusters. So this is exactly how humans reproduce. They send off single-celled propagules, just like these algae, just like, again, most extant multicellular organisms. We can even calculate this. This paper mentions the Price equation is capable of analyzing this. Applying it to C. reinhardtii experiment, delta Z is positive and much higher for the evolved strain than the wild type. This implies that there's a major fitness difference and change between the multicellular individuals and the unicellular individuals, even when they're aggregated. And yes, they do this obligately, meaning that they do it in the same conditions that the unicellular ancestors break apart in. And so this is due to developmental cues, which you were talking about. The program developmental cues, or the developmental plan, has changed genetically due to mutation. This means it's not temporary. It's not a reaction to the environment or the conditions. It's a permanent body present in all conditions. Going over differences between the typical things, which you've said they're not different than. One on the left is the normal palmalloid structure. It has cell walls in it. This multicellular reinhardtii does not have cell walls. The papers go to painstaking lengths to tell you exactly how this is a novel phase not seen before in Chlamydomonas, not even C. nivalis, as you claimed in your presentation, but we can skip that since you didn't bring it up today. Palmalloids differ in both morphology and in cause, so it's not what's observed in these experiments. So you're confusing aggregates or palmalloids with actual permanent bodies. Here are the numerous differences between them. We can go over that some more. That's between the palmalloid and the multicellular, and this is the aggregated versus multicellular. There are 6 major differences. And 5 of these traits are actually unique to the multicellular scene Reinhardtii. They have bodies that are permanent. Their bodies are only consisting of clonal daughters, so they're not coming together with other individuals floating around in the tank like they usually do. They form obligately. There is cell differentiation, and there is unicellular bottleneck. And so these meet all of the definitions of multicellularity. And I gave 4 different citations for that. It's observed in other experiments, same morphology. So yeah, I might ask you to send me the citation you used, but your previous ones did not have any citation on it. I think you said Science Direct, right? And this involves, these things involve modification of pre-existing capabilities of the cell, yes. But the key word is modification. There are new traits, which of course is evolution. So I've got a little bit of time left. That's odd. So basically, I'm going to, I have some things I want to rebut, but I'll go over some of the problems with your assumptions here. So you didn't seem to understand that this is a life cycle that is shared by all or not all, but most multicellular organisms. I don't see how your definition that you gave does not apply to this organism. And one major thing that we might tussle on is this idea that, oh, they said they're clusters, so it's not a multicellular organism. Well, what do you think any multicellular organism is? It's a bunch of different cells. It's a clusters of cells. So cluster is not a word that's going to save you here. It's not like they tried to not use it or something. These aren't stupid people. They're not, this is not a paper trying to prove evolution. It happened. We went over that with our debate last week. If you can predict how something works, you know how if you can predict what something does, you know how it works. So this is a study of evolution, and yes, they do assume evolution because, like almost all papers, they assume all the discoveries and the research that has come before. So seeing as how they're studying how evolution works, they mention evolution. This is the part of evolution that we're studying. Okay, I don't see a problem there. So they're trying to explore how evolution proceeded. So, and even within these experiments, evolution predicted a lot of the features, predicted where what gene would have what effect, based on what they knew about other similar organisms, predicted how it would work. Creation can't do any of this. It can only distort and kind of like, yeah, quote mine, and not understand what's actually in the papers. So I guess I'll leave it there.
Okay, Snake, thank you very much for that opening statement. Let me just double check on what we can throw into the discussion. Okay, a couple minutes there we'll throw into the discussion. We are now moving into rebuttals. And for rebuttals, we have 8 minutes on the clock. And so, Jamie, whenever you're ready, we're going to hand you the floor. And you've got 8 minutes. I'll start the timer on your first word. Go ahead.
Yeah, so the first thing I want to mention, because he seems to really like to lean on this, in our first debate, I said that Volvox was multicellular, but at that time, I had not actually taken the time to study Volvox as its own. The only thing I knew about Volvox was what I read in the papers regarding Chlamydomonas. However, when I went to go study Volvox on its own, that statement is actually questionable. I would be willing to argue that that probably is not a multicellular organism. So yes, we're all learning. We're all constantly gaining new knowledge. And as I studied Volvox a little bit more, I realized that probably wasn't multicellular. So that was a misspoke on my part. I took a couple notes, so I'll just kind of cover some of these notes right quick. First, he said humans are just a cluster of cells. No, they're not just a cluster of cells. They are designed and they are functional in every aspect of the human, from the hair all the way down to the toe. Every piece of that body has a specialized function that you can see the cell differentiation in. Remember that the characteristics of multicellularity, there are some requirements for that, and you showed that slide, but yet you still want to reject these requirements as characteristics for multicellularity. Now, what they have done with Chlamydomonas is, yes, they have filled in some of the check boxes for multicellularity, but they missed the most important ones, which was distinct organs, or not just organs. It doesn't have to be organs. As you said, you claim that I say it has to be organs. No, that's not true. I said it has to be distinct organs or differences in the cells. What we learned is that there isn't differences in the cell. Just because one of the cells is not doing the germline function that it normally could do, which is a loss of function, not a gain of function, and the other one is giving up its motility so that they can work together to survive, that doesn't mean that that's a specialized functions or differentiation. So we're probably going to be going back and forth on that a lot, because what you're claiming is cell differentiation, I'm claiming is a loss of function and is not, in fact, evidence of differentiation. Okay, we don't see specialized functions. A specialized function would be if we saw something new. We're not seeing anything new. We're seeing something that they could do independently, but now they're working together to do it because they've been artificially manipulated to the point where they have to work together to do it. So actually what that is doing is that's making them more dependent on others. It's not making them better suited for the environment. Also, another point that you mentioned was modifications. Yes, it's modifications, but guess what? Modifications are not beneficial to evolution because, again, they're becoming dependent on others to survive. They can no longer survive on their own. They are less adapted to their environment. Also, what I want to know is, how do we have these mutations that cause them to lose information, but somehow losing all this information for millions of years is eventually going to get them gills or legs or wings or whatever? You're showing losses of information and then saying that proves evolution. No, you're going the wrong way. You're going backwards. You need to go forwards. Another thing was, he said the extracellular matrix is functional space. No, the extracellular matrix is what's holding it together, but it's not specifically constituting a functional space. So I'm sure we'll go back and forth on that one as well. Another thing you said was, you literally quoted, it's individual cells working together as a unit. So you're admitting that they are individual cells in this cluster that are working together for survival. I don't understand how you can't see that this does not prove multicellularity. Just because they're working together doesn't mean they're the same organism. Not once in that paper does it say they are the same organism. I went through that entire paper and it never made that claim one time. And that's really the important thing to take away from this, is that if they want to claim that we have made single cell to multicellular evolution, we need to see a multicellular organism at the end of this process. And that's not what we see. We see a multicellular cluster for one of its life cycles. Remember, after that, it branches off, becomes a single cell, reproduces to a single cell. And then those single cells that it's reproducing actually stay together because they have the same mutations as the parent cell. Now, another thing you said was, you mentioned the genetic bottleneck. And I think it's hilarious when evolutionists or atheists bring up the genetic bottleneck, because, again, genetic bottlenecks are not good for evolution. Genetic bottlenecks are losses of information and loss of variety. How does this help evolution? If you have a genetic bottleneck, you are losing information. You're getting less variety in that DNA gene pool. How does that eventually turn a Chlamydomonas into a shark or whatever? That's what I don't understand, is you're showing backwards progress and then you're saying that it moves us forward. Another thing he said was there is cell differentiation, and I kind of already went over that. There is not cell differentiation. They are assigning functions between each other for survival. But again, these are, as you said, independent cells working together. Another thing you said was that if you can do this in the lab, then it can happen in nature. And it's funny because your paper specifically says the opposite of that. First off, if you can artificially manipulate something, that doesn't mean it will happen naturally. Artificial manipulation is a piece of intelligent input. So to artificially manipulate something is showing that in order to make a change, you need an intelligent designer. And then also on that point, I showed the quote at the very end of my opening statement for that, but let me go back down to it and just quote it word by word again. So the paper itself actually said, although it is possible that a controlled population could evolve multicellularity in a few months, and this is them talking about with their intelligent input on the organism, this would be an unexpected outcome. And they're talking about out in the wild, out in nature, naturally, given that hundreds of independent lineages in the genus Chlamydomonas have failed to do so for over hundreds of millions of years. So what they're saying in that quote, and I'd read that directly from the paper, what they're saying is we were able to artificially manipulate this Chlamydomonas to create multicellular cells or multicellular clusters, but it won't actually do that in the wild. Just as you said, or actually just opposite of what you said, which is you said if you can artificially do it in a lab, then it can happen naturally. And your paper says the exact opposite. So again, all that they're showing in this paper is backward progress, loss of information, genetic bottlenecks, all of this reverse engineering, or not reverse engineering, but reverse evolution, de-evolution. And then you're trying to use that as an example for progressing to the next stage of the evolutionary chain. So I'll go ahead and wrap it up with that.
Okay, thank you very much, Jamie, for that 8-minute rebuttal. We are now going to hand it over to Snake for his 8-minute rebuttal. Snake, whenever you're ready, the floor is yours.
All right, so let's talk about artificial selection. It doesn't matter. This is not intelligent design. That's not even close to intelligent design. You're kind of doing wordplay, implying that there was some kind of genetic engineering here. No, this is just artificial selection. The only difference is humans get to decide the environment. That's not intelligent design. So yeah, you seem to have a problem with any intelligent input. I'm not sure how we're supposed to study this. Just stare at a puddle for years on end. So what scientists do is they eliminate variables. So saying that this is just intelligent design is dishonest wordplay. So I can tell you have learned a lot from James' tour. It's not genetic engineering. The only thing scientists are doing is eliminating variables, changing environments, and seeing what happens naturally. They mutate and they adapt, which is evolution. So we pick the environment. Okay, the rest is up to the organism, and we observe it evolving. Anyway, it doesn't really happen in the wild because there are too many variables. That's why we eliminate the variables. In early Earth, these variables were not present because one of the variables would be bigger predators that can eat these. So when there are larger predators, it's actually more advantageous sometimes to be single-celled. But there are multicellular algae. I don't know what definition of multicellular you're using because the Volvox actually is multicellular. You're free to make up your own definition, but it's not the definition being used by any scientists. Yeah, we do expect this in the wild. Some of them have undergone this. And I never said humans are just clusters of cells, but we are clusters of cells. Organs are clusters of cells. Tissues are clusters of cells. Cells are the fundamental building blocks of organisms, which is why some people don't consider viruses to be organisms. So yeah, cluster is not going to help you. It's not a rescue device. They're clusters. No one's ever tried to argue anything else, at least not me. What matters is what these clusters are doing with each other. So you said distinct organs or differences in the cells. So that's not really, so cell differentiation is a requirement. But you talk about specialized function. This, I'm not sure where you get this. Seems like you made that up too. Your rescue device is that it doesn't count because it's loss of function, but it's not loss of function. It's a gain of function. So you agree that they have different functions. But now the reproductive cells have an added function of giving the body a unicellular genetic bottleneck, which is a new function. And this is a positive function. The paper explains this. It maximizes reproductive success of the multicellular individuals because it's no longer competing within itself. That's why it's measurably, quantifiably an individual once it's there. I did the math. I showed you the math on that. So also the soma cells do have a new function that is protecting the reproductive cells and from predation or other pressures. So we are actually moving forward because it is increasing in complexity due to random mutation. So evolution works on trade-offs, and that's exactly what we expect. Modification of existing traits used in different ways. So like a fish using its fins to walk, now they're not just fins, but they're feet. So the better what a fish is at walking on land, though, the worse it is at swimming, and vice versa. So it's about trade-offs. These cells trade off functions for a higher level of cooperation. They are no longer cooperating just by being near each other. They are cooperating by altruism, which is expected in evolution. The altruism being that they lose part of their function to gain a different function, and not only to gain a different function, but to gain a function for other cells around it, meaning that it's a single body. You don't understand what a genetic bottleneck is. It's not loss of function or loss of genes. It's actually a limitation of harmful mutations is one of the functions. It also eliminates competition, which is a harmful thing. So the genetic bottleneck has positive traits. This is in the paper. Maximizes reproductive success of multicellular individual. These are quotes. Unicellular bottleneck limits genetic diversity and hence genetic conflict among the cells. Once a single cell bottleneck has evolved, genetic variation will be efficiently segregated between multicellular individuals. So they're evolving as these clusters, not as single cells. That's why, yes, every multicellular organism is individual cells coming together. Well, actually, they're not coming together. They were always attached to each other. Coming together would be the aggregations, which is not what this is. These cells are born together. They stay together, except when they have babies, just like other multicellular organisms. The extracellular matrix is, in fact, functional organization of space. That is actually quoted in the paper that talks about functional organization of space. I can show that to you. I'll pull that up in a second. I don't want to lose any time. But that was actually one of their top examples of functional organization of space when they're talking about it. And what it does is, the extracellular matrix is not made up of cells, but it binds the cells together, which functions to organize their space, having a clear boundary between other clusters, other cells, and keeps them together so that they can cooperate. They don't fragment. They have single cell babies. They don't fall apart at any point in this experiments. That's not true at all. I don't know what you mean by the phrase it wants to be single-celled, because they don't, because every single-celled baby they have becomes multicellular. They start dividing immediately. And you admitted that they're dependent upon one another because they evolved to be dependent on being a single unit. This is the hallmark of multicellularity. Genetically predetermined, you mentioned the genetically predetermined developmental program. Yes, this program evolved. It changed due to mutations and is now giving a different predetermined developmental program. So now they're predetermined by this Reg A-like gene to have a completely different developmental program. And this was done by random mutation and, of course, selection. I believe I've gone through all of my notes. So yeah, I'll leave it there.
Okay, very good, Taylor. Thank you very much for the 8-minute rebuttal. That concludes the opening statements and rebuttals. We are now moving into the much anticipated back and forth discussion for this debate. Jamie and Taylor are going to be bringing the heat. This is going to be a very engaging discussion, and it's about 50 minutes we have, give or take a few, maybe 50, 55 minutes with the time not used in the openings. And so Taylor did just end with his opening statement. Why don't we give you the opportunity, Jamie, to ask the first question or pick the first point to discuss? Gentlemen, the floor is yours. Go ahead.
Okay, so I had to unmute my mic. I really wish there was a better way that we could do this open discussion, because there's so many different points that you mentioned that I want to talk on. First, I guess let's start with artificial selection does not matter. That's the first thing you said. However, it does matter, because in the wild, we don't see this happening. The only way that this does happen is with a human who has intelligent input to put into this process, going in and manipulating it. That's like saying if we never were to mess with wolves, they would eventually create hundreds of dogs, when we see that wolves never created the dogs without intelligent input. So I think the artificial selection aspect of all of this is a very important point to mention, because how are you going to prove this without intelligent input? Because everything that's been done is based on intelligent input.
There is no intelligent input. You're saying that, maybe you mean to say something else, but you're saying that as if, let me get this off my screen, as if they're actually putting information into it or something. The only intelligent input, so to speak, is choosing what the environment is.
No, that's not true. In the paper on page 2. Okay, go ahead.
And also, yeah, we do expect it to happen in the wild. We expect this is closer to early Earth conditions where there weren't larger predators. The one thing that they mentioned a lot was that in the wild, there would be larger predators than this, but not in the early Earth conditions that they're trying to replicate.
Right. So nowhere in the paper does it say they're trying to replicate early Earth conditions. But what I will point out is, because you said this isn't artificial, you said it isn't artificial selection. However, on page 2, at least 4 times, they say that they used a process of settling selection, which favors large clusters that settle rapidly. So they are using intelligent input to pick which ones they want to move forward with this process. And they're picking the ones that would cluster more, that have a higher possibility of clustering. However, in nature, the Chlamydomonas isn't doing that. So that's intelligent input.
Yeah, they're setting up an environment which kills off certain ones and seeing what survives. So it really does not matter if it's artificially selected or not. They've shown that the genetics of this organism are capable of gaining information, gaining complexity through random mutations. And yes, it states in the abstract that they're trying to replicate the early stages of evolution.
Okay, so let me look at the abstract right quick. It says transition of multicellularity enabled the evolution of large, complex organisms, but this step in the transition remains poorly understood. Here we show that multicellular complexity, including development from a single cell, can evolve rapidly in a unicellular organism that has never had a multicellular ancestor. We subject the Chlamydomonas reinhardti to conditions that favor multicellularity. That's what they are actually doing. They're creating conditions that would cause multicellularity, but that doesn't mean that's the original environment of the Earth at that time where single cell became multi-cell. So
that's
again, that's a built-in assumption.
It's a potential environment, and it worked. It did exactly as predicted, because we know how biology works.
But like, they're literally artificially selecting. They're artificially selecting the environment for multicellularity, which the pre-organism Earth, let's say that the Earth is all single cells at this point. According to y'all's 4 different theories on this idea, that would have been a very chaotic environment with a lot more variables that would have harmed this process than what we see today. So you're trying to bring it to a harder condition for evolving and saying that it's actually better for this, when that's not true at all. I mean, all of the theories that I've heard on abiogenesis, they're all over the place, honestly, but they all have a harsh environment that they're trying to get this done in.
Not if there are unicellular organisms floating around. That's a given. Okay, so there's unicellular organisms. The other assumption they make is, okay, well, if multicellular organisms haven't evolved yet, there's not going to be large predators. Okay.
I understand that part.
So
So
we
I guess
cut out that variable.
I understand that part of what you're saying. I guess what I really need to ask you then is what theory do you ascribe to as far as like abiogenesis and the early Earth? Because that'll kind of give me a better idea of what you're expecting this old Earth to be like. Because there's so many different theories on this condition. There's a water Earth. There's the like the nitrogen Earth. Like, so like, which one do you ascribe to for that?
This has nothing to do with the debate, and this is billions of years after abiogenesis would have happened.
Well, that's all assumptions.
So it has
though. That's
nothing
what I'm
to do with
saying.
it.
Okay, so all right, so you don't want to address.
It's dating of rocks and careful study and stuff.
No,
like
the
that.
dating of rocks is also something we can debate because that's also completely built on assumptions.
You can't debate it because if you're right, the Earth would have melted. It's as simple as that.
Oh, you're talking about the heat problem during the flood? Because we can do a debate on that too, and I'll debunk that in the first opening statement. But since you don't want to talk about the conditions that you would expect this to be in when multicellularity arised, let's go ahead and go to the next point.
No, you said abiogenesis. That's irrelevant. I want to talk about multicellular evolution.
Okay, so then what would you expect? Just paint me a picture of the pre-flood or I'm sorry, not the pre-flood. Sorry, I just finished doing a flood presentation, so it's still in my brain. But give me draw me a picture with your words of what the world looked like when there was only single cells and they evolved to multicellular. What conditions did this Earth have?
So it would be water or wet rocks where algae grows. Where this unicellular algae grows, and there wouldn't be very many other organisms. They'd be competing with other unicellular organisms.
That's it. There wasn't constant volcanoes erupting and all the other variables that they put into these old Earth conditions.
Not on every square inch of the Earth, no.
Okay. All right then. Okay, so the next point you said was we picked the environment and the organism did the rest. That's not true because of settling selection. And then also they created the environment specifically for what they would consider multicellularity. And what they were meaning by multicellularity was, we know this can form clusters. Now, how can we manipulate it to form clusters obligately? So why would you say that they picked an environment and the organism did the rest when the organism didn't do anything? They selected the organism to do that.
Because you're acting like they manipulated the organism somehow by injecting it with something or changing their genes manually or doing it doesn't matter because they mutated due to the conditions they were in, and these mutations gave them new traits. That's what we're studying.
So see, you're trying to dismiss the fact that there was intelligent input because it was simple artificial manipulation as opposed to complex artificial manipulation. So you're saying if they don't actually inject something into this, or they don't actually go in and affect and directly change the DNA code, then it's not intelligent input. And that's not true. Intelligent input, let's say that like this phone is right here on the table and I move it 3 inches to the left. I modified the location of that phone. So
that's how experiments work.
Right, but this is
we decide what we're going to study and what conditions we're going to study them in, and then we observe what happens. So the scientists here decided we're going to see what happens when we create these conditions that favor multicellularity. Are they going to evolve, or are they just going to go through the phases, the temporary phases that we've already observed? They evolved.
But see, that's not what they did. So they created these they've created these conditions that favor multicellularity. And so you're saying from there, the organism did the rest. But that's not true. Every generation, they selected the ones that they wanted to move forward, and they kept selecting until there was nothing left but the ones that are naturally going to form these clusters. So what they're doing is they are not letting the organism do it at once. And if you read
that doesn't mean anything. The organism doesn't,
because on page 2, I'm trying to find the exact quote, but it specifically says that they try and separate from these clusters and they're constantly being selected to not separate from these clusters. So if you were to let the organism do what it wants to do, the organism wants to stay an independently survivable single-celled organism. I'm trying to find the quote right now because
The organism doesn't want to do anything. The organisms just change, and all they're doing is taking out the top of the centrifuge and seeing what was left. What was left was evolved.
I really wish I had this like highlighted in a different color so I knew exactly where it was at, because it literally says on page 2 of this paper that they do try and separate back out into single cells. They don't want to form these clusters. Now, I know when we use the word want, I know
that's not
when
in the
use
paper at all.
Yeah, it is in the paper. It's in page 2
not,
of
and
the
you
paper.
can't cite it.
I'm trying to find it at the same time that we're not having dead air on the conversation.
I know, but I've read this multiple times, and I don't know. Maybe you should have had this. So are you just still reading, or?
Yeah, I'm trying to find it, but I guess we can move on to the next point. I know where it's at, so I'll get to it eventually. Okay. All right. So you said it's not a loss of function. Okay. Explain to me how this is a gain of function, because now some of them are, so they're all dependent on each other at this point, but some of them lost the function to be somatic, and, and then some of them lost the function of motility. So it's not they're gaining function, they're losing functions. And as you said earlier in the rebuttal, they are sacrificing some of their abilities to help others survive. This shows dependence. This shows loss of individuality. This shows loss of what's the word I'm looking for here? It shows that they're losing functions. They're not getting better. They're getting worse. Now they have to depend on others, kind of like how we describe the Amish versus the people that live in the city.
They're not getting worse. They're actually gaining fitness. They're both gaining and losing functions. That's how evolution works. I don't understand why this message can't be understood by the creationists. So evolution works by trade-offs. You change something that's already existing in the gene pool, and usually you're losing its previous function and gaining a new function. This is what we see here. You said it gains dependency and loses individuality, or but actually
more so, yeah, that's more so correct. Yeah.
So dependency is actually gain of individuality of the whole cluster. So if they're dependent on one another, that is a hallmark of a multicellular individual. So the functions that they're gaining are higher level. The papers talk about this. The fitness moves from measurably. It is quantifiable. The fitness moves from the cellular level to the cluster level, or the body level, as I like to call it. But it's the same thing. These clusters are individual bodies. So the fitness now is in the entire cluster. The whole body.
They're not more fit. That's what I don't understand why you guys can't understand this. They're not more fit. Remember that when it was a single-celled organism, it could protect itself. It had motility. It had the germline function. It could do everything that it's doing in the cluster by itself. So now that it's in the cluster and dependent on others to do some of these functions for it, it's not more fit. It's more dependent on others. So I know, yes, multicellularity requires cells to be dependent on each other.
Right.
But if it was as a single cell, it could do all of that by itself, then what we are seeing is a loss of function, because now one single cell in this cluster can no longer do that.
Yeah. So this is what all the studies on multicellularity talk about, is fitness moves from the single cells to the multicellular level. So yes, the single cells, or the individual, the single cells are losing fitness. Yes, the cells in your pinky finger are very unfit. They're completely dependent on you to survive. They have very low fitness. But when they're all connected in a cluster, in a body, in a soma, the fitness goes up. You're more fit with your pinky, and your pinky is more fit with you. So, and what I have on my screen right now is them measuring the fitness of these clusters. It went up significantly. In fact, exponentially. So we observe, so they define multicellularity as fitness moving from the cellular level to the body level. This is what we observe in the experiment, and fitness was measured to go up. So I'm not sure how you can continue to just say the opposite of what the papers actually observed.
Well, I don't think we're going to find any common ground on this, because if you're trying to tell me that it's more fit because it's dependent on others, I don't see how we can find common ground on that. The single cells could do all of this by themselves, and they do it just fine. They can adapt in every single environment. Now they cannot do that. Now they have to rely on others. So in my opinion, and from what I'm understanding as far as adaptability to the environment goes, they are not more fit. They are reliant on others. That would just be like if someone had to go on welfare to pay their bills, they are not more fit because the government's paying their bills. They are less reliant. They are less self-reliant. So I don't think we can find common ground on that one. And
so I'll try to explain it a different way, because you don't seem to understand what these papers are talking about when they're talking about the higher level altruistic functions. So there is the fitness of the cluster, and then there is the fitness of the cells individually in the cluster. There's a difference. The fitness of a single cell within that cluster is different from the fitness of the entire cluster taken as a single individual. So, and this is a hallmark of multicellularity. The cells that comprise the multicellular individual have low fitness as single individuals, but together they have high fitness. So you need to understand the difference between the cellular level fitness and the higher level multicellular fitness, because they're different, because they're acting altruistically. Because we see this in larger populations too. You can say people are altruistic with each other, but that ends up giving the population a greater fitness. Even if you yourself are eating a little bit less, the whole population survives better.
I mean, I understand what you're saying, the difference from the single cell moving over to the multicellular. I understand that. But at the same time, this doesn't mean that it's a better organism. It's not now more survivable in the environment because it's a cluster. It's not going to be able to survive all of the environments that it could have as a unicellular organism.
On my screen, I literally have from this paper a graph that shows probability of survival going up.
Yeah, I'm looking at this same probability of survival graph that you have on your PowerPoint slide. But the thing is, these Chlamydomonas could survive any condition around the world. I mean, they could survive polar conditions. They can survive desert conditions. They can survive in the ocean. They can literally survive anywhere on the planet. Like, the survivability was not a problem for them on the unicellular level. So them saying that now it has a higher ability of survival, that doesn't really show much, because from the beginning, this was a highly survivable unicellular organism.
So what? It doesn't matter. There's no such thing as a better organism. There is only a better organism in a specific environment. So you change the environment, well, guess what? A different organism is going to perform better. I just showed also that this experiment was repeated with the exact same results in response to predation. So there was no artificial selection in that experiment. All the scientists did was just put in predators. So the predators were eating them. That was the selection. The predators were making the decision there. And same results. So the fitness matters relative to the environment. There's no objectively better organism. So yeah, they survive fine on their own. Environment changes and they evolve. That's evolution.
Yeah. Okay. So I guess let's go ahead and go to the next talking point then, because we're just going to keep circling around on that one. Next, he said soma cells have new function. They're protecting the other cells. That's not a new function, because when it was an individual, it could protect itself just fine. But now it's dependent on others and could always protect itself. So how is it a gain of function if it could protect itself beforehand, and now some of them have been assigned the job of protecting the entirety?
Well, in both experiments, and especially the one with the predator, apparently they couldn't protect themselves as well when the predator was there. So again, it just matters what the environment is. So the soma does not have altruistic behavior in the aggregations or the palmelloid wild type phases. So they're still competing with each other, even when they're cooperating. In this, the soma are not competing with the reproductive cells. So that is a new function. They have a body that's permanent. That's another function, which doesn't compete with itself. It's a very important new functions.
So you're basing all of this multicellular evolution based on the fact that they're no longer competing with each other and they're actually working together, but we've selected them to do that. We've selected them to work together and be dependent on each other within the cluster. That's what the multicellular life cycle is. We chose that to be their life cycle.
All we did was pick out which ones were evolving and separated them. In one of the experiments. In the other experiment, all we did was introduce a predator into their tank, and they evolved without
right, but
any.
none of this is new. Like, they do it in the wild. They can form clusters in the wild, and they can live in these clusters. I mean, that's why when I do the PowerPoint, I show the reproductive processes, because it shows in the reproductive processes they can stay within a clustered state for a long majority of time, especially in polar regions. They'll stay within this multicellular cluster until the environment is more adaptable for them to go back out and reproduce.
So this seems like you forgot what I just said. Is these clusters, they're different types of clusters. In the experiments, they're altruistic clusters working as a single individual unit. In the wild type, for this species, there are multicellular algae. They work, and the unicellular algae, rather. There's both. But in the wild, the unicellular algae do not work altruistically together. They just kind of huddle together and then break apart when conditions get better. In this, they're actually, the soma are actually taking a fitness hit so that the entire cluster does better. That is multicellularity by definition, that to a T.
Oh, I'm really trying to find this quote, because this would really just end this whole argument right there, because they're not staying inside of these clusters naturally. We are forcing them to stay in these clusters. But aside from that, what you're saying is that when it goes through, it's in there. I know it is. I have it highlighted in the blue section. I just didn't separate it from the rest.
Show me the money.
Yeah, so give me a moment on that. But what you're saying, though, is you're saying that in all of these reproductive processes, the palmella, the aplanospore, all of the sexual reproductive process, throughout these entire processes, when they're forming, when they're reproducing, that they're competing with each other. They don't work with each other at all during that process.
I didn't say they don't work with each other at all. I said that they are still competing.
Okay, so
that's what the single cell genetic bottleneck means. So there's all bottlenecks are not equal. So we're talking about specifically the concept of the single cellular genetic bottleneck, which is not a population getting so small that it goes through a genetic bottleneck. This is an individual reproducing with a single cell. That's what that means. And that's actually better for the population because one, it eliminates a lot of the harmful mutations, because mutations can happen in the soma and it won't affect and it won't pass down through the reproductive cells. And it also helps reduce competition, genetic competition among them. So it's one unit working as a single unit, because they don't work as individual cells anymore. So they are a unit, which is multicellularity.
Okay, so I think I found the quote that I was looking for here. Let me switch this over to screen right quick. Oh, you're not going to be able to read it anyway. Okay. So on page 2, just like I said, oh, perfect. On page 2, on the right-hand side, there is you see some blue, and then there's a big chunk of yellow on the right-hand side. So I'll read a little bit of the blue first. It says, during the first 24 hours of culture, actively swimming solitary cells were present in the population, suggesting that clusters reproduce via motile unicells. To confirm this, we examined cluster-level reproduction using a time-lapse microscopy. Here's the part that starts to get into what I was trying to make the argument for. No cells dispersed from the cluster during the first 4 hours after transfer to fresh medium. After 4.16 hours, cells in clusters began to activate their flagella, causing the cluster to convulse rapidly. This change in state from stasis to movement took 3 minutes. 6 minutes after the onset of flagellar activity, the first motile unicellars broke free from the cluster. 5 hours after the transfer to fresh medium, many of the cells in the clusters had dispersed. So yes, the entire time they're trying to disperse from this cluster. That's what I was trying to get to. That's the point I was trying to make, is that they didn't naturally do this. We are forcing them into this.
How are you suggesting we force them into this? They're doing it on their own. But I anticipated this. I already pulled this quote because I knew you would misconstrue it. What they're describing there is the single cellular, maybe I'll put it back up. The single cellular propagules, it's babies in layman's terms, coming out of it. So this is it reproducing. It shoots out motile individual cells. That's how it reproduces. We're just watching it reproduce. This is not the clusters just disintegrating, and we're doing nothing to manipulate them to stay in clusters. This is just, they actually, it was about halfway through the experiment that they actually started noticing these clusters forming. So they didn't have to separate them for the whole experiment. These took over the entire population, and these babies grew up to be multicellular.
Yeah, but they didn't take over the population. We selected the ones that did this and removed the others from the equation. So you're saying that they took over the population, and that's not true. And that goes back to the whole stumbling block that evolution has in the event that if one organism makes a change, now what do the rest of the organisms have to do? They have to disappear. They have to branch off and be completely independent from it. And how does that one organism now create an entire new species? So see, you only jump over one hurdle to create a whole nother hurdle.
But you don't understand evolution at all. It's not done with a single individual. It's single individuals have mutations, and those genes spread throughout the population. So what they were doing in this experiment is simulating an environment where unicellular algae are killed more often. So they didn't kill all the unicellular algae, but they were simulating selection where certain ones are killed. They also did this with a predator in which they were actually killed by a natural organism, not selected for by humans, and they got the same results.
Yeah, but see, I don't see how you're not seeing this. This is all selection. This is all us choosing what goes further. And again, in nature, that's not what happens. In nature, let's say one of these Chlamydomonas did in fact do this in nature. Well, now that one Chlamydomonas cannot blend back into the rest, or else that mutation is gone.
Well, it can reproduce asexually. So as long as it's not being selected out, it will probably keep going on. But what they're doing is simulating an environment where the single cells are at a disadvantage. So there are environments like that. And,
right, but again,
when they used the predator, they got the same results. No humans were selecting.
Okay, so let's go back to your version of old Earth, right? The planet has all these unicellular organisms. The planet is perfectly accustomed, or the organisms are perfectly accustomed to this. So what is going to make them move from being unicell to being multicell unless the planet just drastically shifted its conditions?
This is what the papers are about. So with the pressure selection, what they're doing is selecting with basically access to light and pressure. So the larger clusters are able to withstand more pressure, and but they couldn't get too big or else they would die from lack of light. They also tested whether a predator, which can exist as multicellular or single cellular, would have a similar effect, and it did. So yes, the single cells can eat each other. That's a natural condition. And cells can, so for example, if cells near the surface of a pool were more likely to get killed off, perhaps by radiation or something, then the cells at the bottom, which would be clusters because they're heavier, would survive better. So they're just testing different variables, and with some of the variables, they get the same results, which is evolution. So we know it's possible. Information can come from mutations.
Right, but we're not seeing new information, though. We're just seeing it use the same information in a different way. So
That's
again,
new information.
It's the same information. It's just being used in a cluster form instead of a unicellular form.
It doesn't matter. If you have code and you trigger your code with a different trigger, then that's new information.
No, new information.
Or you change
new DNA,
or it turns on. That's new information.
Yeah, new information would be new DNA, a new function that it didn't have prior to this process.
It has both new functions and new functions.
Okay, so where is the new DNA on this Chlamydomonas then?
In the nucleus.
Okay, where does it say that? Where does it say anything about the new DNA?
It says that the changes were genetic.
Okay, but what are the specifics of that? Again, you want to hold my feet to the fire, and you want to hold my feet to the fire and tell me to give you specifics, but then you just make a general broad statement. Where is the new DNA on this organism?
What are you asking for? Where is the DNA? DNA is located in the nucleus.
I'm saying, what is the new DNA? What is new about it? You said it has a
What's
new
new about it?
Yeah, you said it has a new genetic feature. So what is the new genetic feature? Where's the new function of this? Because all the examples you've shown so far are things that it could have done by itself, and now it just does them in a cluster.
No, because they're clustering completely differently. So before it was triggered by an environmental cue, and now it's not. It's just the necessary developmental plan. So this is a study of how that gene works. The title of the paper is down at the bottom. My little snake is kind of covering up the first word. It says evolution. But yeah, so these genes turn on and off in different cells, which is cell differentiation. That's how cells differentiate in more complex multicellular organisms as well. And so this is describing the behavior of the gene. The soma turns off its reproduction, and together the whole cluster survives better.
Right, but so again, there's nothing new about that. There's no new sequence of DNA causing that. Like they all had soma, they all had germline, and now they're so they all could do this at one point, and now some of them can, some of them can't. That's why I don't understand why you can't understand this. Like, you're such a smart guy, but you're not seeing the obvious here. Like, you've complicated things to the point where you can't understand obvious concepts. They can do all of this. The obvious concept is that this unicellular organism could do every single thing that you're claiming is a new feature.
That's false. Why have you already forgotten all the functions that the wild type can't do that I listed? I listed 5 functions that the wild type cannot do and did not do before these experiments.
Wait, do you have the slide for that? Pull that back up. I think that's one of the ones you slid through pretty quickly.
Okay. I will
So
pull
pull that one
up.
back up. Let's go through that
But
one.
first, I'm showing you what they sequenced to tell that they actually did genetically change. It's known that the reggae gene, what it does in multicellular Volvox. Let's see here. And these organisms have the same gene. It's toward the bottom somewhere. Here it is. So the clusters in the wild type do not have only clonal daughters. They do not have permanent bodies. They do not form obligate clusters. They don't have cell differentiation, and they don't have unicellular bottlenecks. So these are all new traits, features, and functions just by changing what was already there, how it's implemented, where it's implemented. That's functional organization of space. Is it showing?
Okay, so first off, the cell differentiation, again, we're not going to agree on that one. It's not differentiation because it's not specialized functions. They all had these functions previous, okay? So
where do you get that definition of cell differentiation?
Let me pull up my PowerPoint right quick. I won't put it on screen, but I'll just pull it up so I can look at the references. So for cell differentiation, oh, where do my references go? Uh-oh. Hold on one second. Pulling up. Okay, here's the references. I moved them for some reason. So as far as the definition for cell differentiation, that one comes from... Oh, man, I don't know which one of these it came from. I need to go back and mark all of these.
Well, all that's needed is every cell in your body has the same DNA, except red blood cells that don't have DNA, mostly, other than a couple point mutations. But the differentiated cells switch on different genes. They all have the same genes, but they're utilizing different genes at different times in different places. This is what we're seeing with the Chlamydomonas. They have the same genes, but some of them are using them, some of them are not, and they're both using certain genes differently than the wild type. So here's a definition from the National Cancer Institute. Cell differentiation is the process during which young, immature, unspecialized cells take on individual characteristics and reach their mature, specialized form and function. And so this is exactly what we see with these experiments, is some of the cells mature into non-flagellated, non-reproducing cells. The others mature into flagellated, reproductive cells. So this is cell differentiation by definition.
Okay, so I found the definition over here. So the true definition of cell differentiation is the process in which a cell alters from one type of cell into a different one with a specialized function. This specialized function consists of a new design that did not previously exist prior to differentiation. And this comes from bijust.com/biology and study.com, which are both sources that are used by students for doing research papers.
What is it from?
Bijust.com, byjus.com/biology and study.com. So again, where is the specialized function? You know, there's no specialized function here. They're assigning roles what they already could do. In order to have a specialized function, it needs to be something new.
They absolutely have specialized functions. One is soma, one is a gamete. So they have specialized function. I'm not sure where you're getting this claim that they have to have a new design that did not exist before, but they do have functions that did not exist before together as a single unit. I'm not seeing this extra part you've tacked on your sources.
What do you mean the extra part that I tacked on?
This thing about how it has to have a special function that didn't pre-exist, or however you've phrased it.
Yeah, so let me go back to that for you. This
not on your slides. I want to see what peer-reviewed sources you're using.
Yeah, that quote on that slide comes from either bijust.com/biology or study.com. Those are the two sources that I went to for the exact words on that slide. I'm not just mixing and matching definitions. That's directly copied and pasted from those sources. So yes, there is my sources.
But I think you are tacking on, because cell differentiation does not always have an evolutionary context. So when biologists define cell differentiation, or teachers teach cell differentiation, they're not talking about evolution, they're talking about development. So they're not going to talk about having a function that they didn't previously have, like evolutionarily speaking. They're just going to be talking about changing function from that has a different function from the other cells around it.
Right, but again, this is not cell differentiation. Okay, this is them already. Okay, so again, I don't
They
know how
have
many
different
times I have to
functions due to
they have
mutation.
they're still using the same functions that they had as unicellular organisms. They just are assigning the roles to different ones inside of the cluster. There is
So that's cell
nothing new
differentiation.
about them. There's nothing new about that, though. All of them could do that before this happened.
No, they couldn't. There's 5 traits that they couldn't do before that happened, and that doesn't matter anyway. It doesn't matter if they had this, if they had all these traits before, and now they're just differentiating. That's nowhere in any definition. That's not how scientists use the word.
You want to remove specialized function, but you want to keep differentiation. You can't do that. The specialized function is part of the differentiation.
What
and
part
no, it's
of
not.
what
Look
part
at
of
the slide
one
that I have here? This is cell differentiation. Okay, this is not cell differentiation. These are a cluster of cells that they could already do that. They already had the ability to aggregate into clusters. They manipulated them to the point, and not by changing their DNA, but they manipulated the environment to force them into these clusters. And then once they became dependent on these clusters, they now are assigning roles. That's all that's happening here. This isn't something that would naturally happen in the wild. And they say that in the paper. They say it in the paper that this is not expected to happen in the wild, because we would have seen it already over the millions of years that this could have happened. That's the biggest stumbling block that y'all have in regards to this paper. This paper specific, I'm not trying to run over you here, but I just want to make this point. The paper specifically says, although it is possible that a controlled population inside of a controlled environment could evolve multicellularity in a few months, which again, I wouldn't necessarily say this is multicellularity, but still, although they were able to do this in the lab with a controlled environment and intelligent input and all these resources that were keeping the environment in this nice, pretty condition, next part of the sentence, this would be an unexpected outcome given that hundreds of independent lineages in the genus have failed to do so over hundreds of millions of years. So they're literally saying this would not happen in the wild.
Modern day, correct. And, a few million years back, no.
Well, isn't that convenient?
They also expect it.
Possible today, but it did happen. That's like the obvious
there's an explanation for that. What's wrong with that? What's wrong with having an explanation?
It's an excuse. It's not an explanation.
It's called science.
No,
scientists study why things do and don't happen. There are variables. They try and eliminate variables. They discuss the variables that are not present, and you have a problem with that for some reason.
No, this is an excuse because it won't happen in the world in nature. It won't happen. So now you have to make up some fantasy past Earth that this could happen in. And again,
it's not a fantasy.
It is a fantasy because you don't know the conditions of the Earth 10 million years ago. You don't know those conditions.
Some of the conditions.
So you don't.
What we're studying is it doesn't matter. What matters is what variables we study.
It matters because you're building that assumption into your study, into your research, into the data that you're pulling. You're saying, if we had this Earth condition, this could happen, but you didn't have that Earth condition. Okay. That's the problem, is that's an evolutionary assumption.
No, it's not.
No, it's an evolutionary assumption. Then prove that Earth. That's what I'm saying.
We can look at the rocks and see that there were only unicellular or very small, no macroorganisms. So we know that there was conditions on Earth at one point in time that had only these kind of small or unicellular organisms. So no, this is not just a blind stab in the dark. This is a very desperate rescue device of, they did it in a lab, so it doesn't count.
No, that's not what I'm saying at all. What I'm saying is what they admitted is that what they did in the lab would not happen in Earth unless the Earth was completely different. And then they build the assumptions based on other assumptions that were built into geology. Okay, you look at rocks and you say this one layer proves that the Earth was different at 10 million years ago or whatever. But again, the entire geologic column is a assumption from evolutionary interpretations. Everything about the pre-Earth with all the Jurassic and Cambrian and all of these different time scales that y'all have created, those are all assumptions, okay? So you can't use assumptions
they're
to
testable.
prove they're not testable. How do you test that?
Oh my gosh. So if we're wrong about that, again, the Earth would have melted. So we test it with various things. One of them is just direct observation.
No. I want to hear you.
One of them is direct observation.
Why would the Earth have melted? Explain that.
They can actually just look at the rocks and see what populations were present at the time. Now, you want me to explain the heat problem?
Yeah, I want to see what you're talking about. Are you referring to creation's heat problem, or is there another heat problem that it goes into the variable of evolution? What exactly are you referring to with the heat problem?
The heat problem of accelerated nuclear decay. So if we don't know anything, if nuclear decay doesn't work as we think it works, which we predict how it works and we get predictable results, and their entire industry is based on it because it's necessary to get accurate results. If all of that was wrong, then it would produce too much heat.
What are you referring to? What would produce too much? Are you talking about like nuclear power plants? Is that what we're talking about?
Why would I be talking about that?
You lost me on your explanation. What are you referring to? I'm sorry. Go over that again.
We can date rocks using nuclear decay species. So nothing to do with nuclear power plants on the Earth billions of years ago. We know the rate at which they decay. If that rate is wrong, then it would be...
Snake, are you basically, in order to maybe clarify for Jamie, are you essentially saying that if decay rates during the flood year were accelerated, the production of the extra decay essentially would result in a lot of heat and radiation?
Yeah, that's what I was getting to.
Okay, so we're talking about the flood then. Okay, so here's the thing.
Not necessarily.
Okay, so here's the thing with the decay rate.
If we don't know what the decay rate is, then if it's faster than what we think it is, then we have a heat problem. Whether you're proposing a flood or not, it doesn't matter.
Okay, so as far as decay rates go, there's a lot of assumptions built into this alone. The first assumption is that decay rates are constant, and they're not constant. We see that all the time when we do carbon dating, plutonium dating. You can go to four different facilities. You can go to 4 different facilities and get massive changes in your decay rates because that's how they test the dates is with decay rates, but they're not constant. Are you different numbers?
Are you comparing the decay rate of carbon versus the decay rate of uranium? Because those are different.
Well, what I'm saying though, no, I'm saying within any specific element's decay. Okay, any specific element, pick your poison. They do not have constants. That's why when you go to get something dated. When you go to get something dated, they ask you where it's at, where you found it, and then they base that off of they adjust their formulas based on that because decay rates can give you wildly different numbers. You can go and get one sample tested at lab A and get 10,000, and then go to lab B and get 10 million. That's a huge difference in numbers. Now this
is based on creationists not doing their science right, so they obviously get the wrong numbers. But
because I'm not talking about creationist labs. I'm talking about labs that's what they specialize in is in carbon dating or plutonium dating or
creationists will send the wrong samples and not give them enough information, and so they'll say
that's exactly what I'm saying. They have to have a certain amount of information to base their formulas on how to date this.
Right, because creationists will send in
it's because
they'll send in the wrong rocks. They'll send in the wrong rocks.
It shouldn't matter. I should be able to give them a rock and they test it and give me an age. I shouldn't have to give them where it was from, what country it's in, how deep was it. These variables are the assumptions that they're building into it from
No, they're
evolutionary
not.
perspectives. And that's
Nope,
exactly
because
what it is.
matters. It matters what the composition of the rock is, because they try and eliminate contamination. They try and they have to know what series they're dating. So you have to know what the rock is to know what's in it, to know
Right.
what
They
you're
have to know
testing
which
for.
they have to know which geologic column it's in so they can date it correctly according
They
to their
don't.
Bible. That's exactly what's going on. And the other
Nope.
point I want to make, the reason that they have to do that is because decay rates are not constant. And the whole thing, the whole
Wrong.
idea of constant decay rates is based on the assumption that the earth has already reached 50,000 years.
No, it's
So
not. It's based on direct observation. We can take a decay series and see how fast it decays. It's called a half-life. It's direct observation. This is not an assumption in
doesn't mean
any
that
way,
decay rate is
shape,
constant.
or form. The only
That's-
way that it has ever been observed to speed up decay, it's not actually speeding up decay. It's actually causing a nuclear reaction by bombarding it with electrons, which is more akin to how a nuclear bomb works, which is not decay. It's a nuclear reaction. You're actually you're making particles collide with each other, which causes a reaction in the nucleus, or electron capture. And so unless you're proposing that the rocks were bombarded with electrons and superheated plasma as your solution to the heat problem, which would just make it worse, I'm not sure where you're going with that.
No, what I'm trying to focus on is the decay rates themselves, because there's a lot of assumptions built into decay rates. And you want to try and, cut me off and not let me explain it, because there's built-in assumptions to it. First off, you have to have a 50,000-year-old Earth for any decay rates to be measurable. Second off, when I say decay rates aren't constant, just because you measured them within today's Earth, that doesn't mean that 1,000 years ago that decay rate was exactly the same. It could have changed since then. We can manipulate the speed of light. So why can't decay rates change? And we can see decay rates changing.
Because decay rates are based on quantum subatomic particle physics. So the decay rates can actually be predicted completely by our quantum models without knowing anything about the decay rates. They come out with the exact same numbers, which is called cross confirmation. So the actual physics of the subatomic particles is, so if you have different isotopes of an element, it would affect how stable the core is. So if you have like an extra neutron or something, that's going to change the way that the nucleus of the atom is actually interacting with the other subatomic particles within itself. And sometimes that knocks out a particle. Sometimes it lets it capture a particle. And this is why there's a decay rate. So you can't just change the decay rate like, oh, I'm just going to like go into the program and change the values. No, because it is based on fundamental quantum reality of how these particles interact.
Gentlemen, before you respond, Jamie, we do have just a couple minutes left. And so maybe we should circle back to specifically the topic of single to multi-cell evolution. And of course, Jamie, if you'd like to quickly respond to anything there, you could. But since we only have a couple minutes left, why don't we make sure we are engaging all of the points necessary on the topic? So, Jamie, go ahead.
Yeah, I didn't mean to go down a rabbit hole there, but I mean, in order for them to say that this would be the environment that would cause multicellularity, well, now we have to prove this environment, which is again a built-in assumption. So I guess the next talking point we can look at, because I made a couple notes here from your responses. Let me see, which one do I want to bring up? Okay, I guess let's look at genetic bottleneck. So you said that the genetic bottleneck does not mean a loss of information. It does not mean a loss of variety. So please explain to me how this genetic bottleneck would cause more variety or more information.
With a unicellular bottleneck, defecting cell lineages rarely succeed beyond the lifespan of the multicellular individual. So this helps the cluster as a whole by getting rid of defecting lineages, which are basically less fit lineages. So you see the red cells here. These are basically have bad mutations. So if all of these cells were allowed to reproduce, then you would have these bad cells reproducing. The clusters would be malformed or something like that. But what happens is only a small number of the cells are allowed to reproduce, and so that helps cut out bad mutations. That's one thing. The other thing is that it helps reduce among cell genetic conflict. So now the individual is not competing with itself. This is one way that we can for sure know that it is an individual. The whole cluster is an individual. It's not a cooperation of individuals, is because they aren't competing with each other on the cellular level. They are only different clusters are competing with each other. So this means that these clusters are in fact individual multicellular organisms.
So you seem to dodge the whole question that I was asking. This isn't what I asked you about. What I asked you was, how does a genetic bottleneck provide new information? From what we see, a genetic bottleneck is condensing down the information, so we're losing information. So where does the new information come from? What you showed was it selected things to remove, and then somehow that's supposed to provide new information. Where's the new information at?
Well, I don't think you know what you mean by information. So define information. It's just a buzzword for every creationist I've ever talked to.
Okay. So when I'm saying new information, I'm referring to a new function, something that it did not do previously.
That's what I described. I described new functions. So that's new information.
Where's the new function? Let's go through that, because the single cell could do everything you just mentioned.
I don't know how you could have just forgotten what I just went through. These are functions of this bottleneck. Defecting cells rarely succeed, so it has the function of cutting out defecting lineages, and it has the function of minimizing among cell genetic conflict within the cluster. Those are functions. So that meets your definition.
That is not a function.
That is a function.
That is absolutely not a function. Because
what do you mean by function?
The ones that are defective are being weeded out means that that's a new function. That's not a new function. That's just the cluster trying to survive, and it's cutting out the ones that are not contributing to the cluster. That has nothing
to do with. It's a result of the morphology and genetics and the life cycle of this organism. So it is a function of this organism. In English, I don't know what you mean by function.
All right, so I see that you have a very gray area of what is considered a function. Then that would not be what I consider a function.
So define function.
Yeah, so when I'm referring to a function, that would be something like, now it can breathe air as opposed to photosynthesis. That's a function. That would be a new function. I'm sorry.
That's not a definition. That's an example.
Okay, well, yeah, that's an example. That's the kind of example that I'm looking for. So
I asked for a definition. So just look up a dictionary. Function, an activity or purpose, natural or to be or intended for a person or thing. So an activity that's natural to a thing. This is an activity that this thing does. So it's a function by definition.
Yeah, but it's not doing it naturally. It's doing it in a controlled environment where it's being selected to do that.
It doesn't matter. Whether it's an artificial function
that is done naturally
or a wild function. It doesn't matter. It's a function that's evolved. So you just agreed. Next point.
Okay. All right, sure. So again, I wouldn't consider that a function, but sure.
Well, when I defined it and said it meets the definition, you said, yeah.
No, because it's not natural. It's not a natural function. We are selecting it to do this.
It doesn't matter. It is a function of this organism.
All right.
So now you're moving the goalposts back to it was artificial selection, which again doesn't matter.
But that is the whole basis of this paper, is they artificially selected it. And then they specifically said at the end, this would not happen naturally. They literally said that. And now you're wanting to say
the same thing happened with predation.
Yeah, but again, they literally say in the paper, outside of the controlled environment that is being controlled by an intelligent source, which is the scientist, outside of that environment, this would not happen. And they literally say, we know this would not happen because otherwise we would have witnessed it within the hundreds of millions of years.
And why is because there would be different environments when multicellularity would have evolved under the evolutionary timescale versus today, where we have all kinds of organisms that have evolved.
Yeah, but that's all. See, again, that's where you go back to assumptions. You're assuming that there was this world previous to what we can see and observe and actually test. You're
Already
assuming that
debunked
this
that.
world existed. No, we didn't debunk that, okay? Because we went down
Yes.
the rabbit hole of decay. And again, I'm going to argue that till the day I die because you can't prove
I know,
any of these
because
world
it's
conditions.
because you don't care about the data, you just like your conclusions. But
No, I
we
do
can
care about the
tell-
data, but the data doesn't show that the Earth was this unicellular world a long time ago.
does.
What the
It
data
does.
shows is the data shows that there was a flood that organized things hydrologically, and that's what we're looking at. And you're putting an evolutionary interpretation on that, just like I'm putting a creationist interpretation on that. The problem
Nope.
is, I will admit my interpretation is my belief, and it's based off of my logic and reason. You won't admit that yours is a belief. You want to say yours is a fact, and it's not a fact.
It is a belief, but it's not a unsubstantiated belief, unlike yours, because I actually have a method, and unlike your hydrologic sorting, that method produces 0 results. It's not accurate. It can't find anything, but the evolutionary method does. So it actually doesn't really matter for this point how old the rocks are. We can tell what the environment was. We can tell like composition of certain things, even in the air. We can tell what kind of biological niche they lived in. We can tell what what other populations of organisms were during that time. So yes, we do know a lot about the environment of the early Earth, no matter how old it is.
Yeah, and a lot of the things you listed were, again, built on assumptions that come from your evolutionary belief.
What I just said has nothing to do with assumptions or evolution. You can ignore all that. The rocks show certain conditions and certain populations, period. That's not arguable.
The rocks don't. Okay, so I guess we're gonna have to do a whole debate on this alone because we keep going down this rabbit trail. But the rocks do not show this. You're interpreting that. What you see in the rocks is you see layers of rocks. That's what you see. And so now you're adding an interpretation on that.
You see different compositions of chemicals in the rocks, and you see different compositions of populations of organisms in the rocks. So there's no interpretation there. It's just pure observation. What is in this rock?
Well, yes, the interpretation is before you start comparing all of these different layers, you start by saying all of these are different time frames. Now let's look at the data and make that fit with our interpretation. And then that's when you come up with this idea of, oh, in this part of the time frame, this was what the Earth looked like. But you're completely ignoring the possibility that all of these layers are the same age and happened at the same time. Because if you did that, you would come to different conclusions.
If you assume a globe, or sorry, I'm talking flat Earth, not globe, a flood model, then you would obviously have different interpretations. But I'm making as few assumptions as possible. And in fact, these papers even go out of their way to say they're making as few assumptions as possible as well. At least one of them.
Yeah, that's not true because as you saw while I was scrolling through the paper, all of the red is their evolutionary assumptions being put on it. And I didn't even highlight all of them because some of them I wanted to keep yellow so I would remember to reference that. But I mean, literally the first sentence, the transition to multicellularity enabled the evolution of large complex organisms. Okay, pause right there. That alone is an assumption. They're saying, oh, evolution happened. Now let's prove it. That's the first sentence of the paper.
No, they're not. They've assumed evolution because the scientific consensus is that evolution is already proven. This is not a paper trying to prove evolution. I use it to try and prove evolution to you, but the purpose of this paper is to study how things evolved, what kinds of things
to prove
might
evolution.
No,
Yes,
they've
that's
already,
exactly what it is.
these authors don't even know you guys exist. As far as most scientists are concerned, creationism is extinct. They're surprised it even exists still. So they say this, what they're studying is, how did this happen? They're not trying to prove that evolution happened. They're trying to show what.
No, that's exactly what they're trying to prove, that it could have gone from single cell to multi-cell. And it literally said at the very beginning.
No, they're studying how it might have happened.
Exactly. They're trying to prove that it could happen. Why would they study how it happened unless they were trying to prove that it did happen? They don't have the evidence that it did happen. Otherwise, we'd be debating that instead of this.
No, you can establish something happened and still want to know how it happened.
Yeah, but how did they establish that? Based on the assumptions. That's what I've been saying this whole time. Everything is based on assumptions when it comes to evolution. Just like creation puts their interpretation on things, and we are willing to admit that. Our interpretations create what we are going to assume when we look at the data. You are doing the exact same thing with your philosophy of evolution. The difference is we admit ours is a belief. You won't admit yours is a belief because you want it to be a fact.
I already admitted it's a belief. And if we believe, okay.
Yeah, you didn't necessarily admit
we believe in facts.
What you said was it's a belief that's a fact. So no, no.
Yeah, it is.
It's a belief.
Because we can prove it. So this is what I was talking about, is a paper that was trying to define evolutionary multicellular individuality. This is the equation that I used to show that it was an individual. But this part here is, they say the approach we have taken here is to present a take nothing for granted view on the evolutionary transition. So they're actually
so pause right there.
Trying to make as few assumptions.
Read that sentence again. Read that sentence one more time.
The approach
Donnie, can you full screen that? Donnie, can you full screen that so we can see that a little bit better?
The approach that we have taken here, which is to present a take nothing for granted view on the evolutionary transition.
Okay, pause right there. They're saying take nothing for granted, but it has to be evolution. You see that? There's the assumption right there. They're not keeping an open mind to it. They're trying to prove evolution. That's exactly what they're doing in that sentence. They're saying what they're saying is we're open-minded, but only about evolutionary transition. We won't consider the other side.
But the thing is these papers are not refutations of like creationism. They're only brought up in these discussions. But the purpose is not to like refute creationism. So that's not what they're talking about. They're not.
Yeah,
they're not.
I understand that, because they want to ignore creation as much as possible, because anytime they bring creation to light, now there's a lot of problems that we can bring up that they have no answers to. A perfect example of this is, as you can tell with Donnie and his specialty, ERVs. Like, they loved tuning that around until it was proven wrong. And this is the same thing that's happening with Chlamydomonas. The problem is I'm the only one that's willing to dive into this. Apparently, no one else wants to dive into this. But yeah, I'll learn more and I'll continue to study all these talking points that you have brought up. But every time I look at one of your talking points, it doesn't prove any of this is new. There's no new functions in this.
I don't know how you have already forgotten all the new functions I gave you. But to expand on this point, what they're talking about is in working toward a mechanistic, take nothing for granted account, we begin by recognizing the standard Lewontin formulation. But so they go on and talk about the things. The part of the sentence I wanted to highlight was the mechanistic, take nothing for granted account. So what they're doing is they don't even have creationism in their minds. Like, again, they don't even know you guys still exist.
Yeah, that's called
what's happening here is they're trying to figure out a mechanistic take for each step and not just say, well, it just happened. So they're actually trying to account for each step instead of like creating gaps and jumps that are just kind of assumed. So they actually do this work to the standard that you would want. But yes, all scientific papers make assumptions about the data that other scientists have done, about the consensus of the field. So that I don't see how that's a problem.
Well, again, and I honestly don't know how many other ways I can say this. They all are required to believe evolution. Like, they are not allowed to think outside of that box. So yes,
No, they're
every
not.
single one of their papers, every single one of their researches that they're getting paid grants for, every single thing they do is revolving around the idea of evolution. They never
No.
look outside of that box. That's why they don't consider creation, because they were taught to not consider creation. Because for
No,
those of us
weren't
that
taught
did
creation.
learn evolution, and then actually considered looking at creation, every single person that I know that's looked into creation, aside from the militants like yourself and the others that's their whole goal is to promote evolution, like Dan Cardinal, for example, every single person outside of the militants that considers creation, majority of them convert over to creation. That's why creation scientists are popping up all over the place right now. There's plenty of them converting over to creation, and that's why we have more organizations coming about. That's why we're getting more studies out there. And yes, eventually we will be able to take back over science, but for now, evolution has the stranglehold on that.
That's some nice wishful thinking, but the exact opposite happened. All the scientists were creationists, and they were all convinced towards evolution over these hundreds of years. So there's no requirement to believe in evolution or to even write about evolution. Do you know how hard it is because I'm looking for papers about evolution, and 90% of the papers I come across, even when I type in the keyword evolution, trying to look for things, they don't mention evolution at all. It's just the mechanistic stuff about this organism that they're studying. They don't talk about how it evolved. They don't talk about how it's relevant to evolution. Most of the papers don't do this.
This paper right here talks about evolution for a whole third of the paper.
This paper does. Some papers are about evolution, but you said they always have to mention evolution.
If you need papers that talk about evolution, I will give you papers to talk about evolution.
I didn't say that there are no papers to talk about evolution, did I? I said that most of them don't, even in the biology.
Every
so it's
single
not a requirement.
paper I've looked at has somewhere in it that it slips in evolution in one form or another. So yeah, every single peer-reviewed paper I've read has to put evolution in there as the conclusion. I have yet to see. Okay, so
I'll send you a bunch that don't mention it at all.
Send me some papers that say nothing about evolution, because there's only like 3 sources because remember, for this PowerPoint, I tried to get my definitions from places that don't promote evolution or creation. And there was very few that are not on one side or the other. Very few. So I think that is a straw man. I think you're building that up to break it down.
Gentlemen, we are at it's been a thorough conversation. Let me just check the timer.
Fix your mic, Donnie. It's staticky.
Oh, is it staticky for you, Taylor?
It was a little close, but it seems fixed now.
Sounds better now? Okay.
Yeah.
So we are at about an hour and 13 minutes just for the discussion. So maybe we'll wrap it up there, but we still have 5-minute closing statements each. And therefore, if there is anything left hanging, something you'd both like to address, we can do so in the closing statements. Jamie, you started us off with your opening statement, so we'll give you the first closing statement. So whenever you're ready, let's say about
go ahead and give it to Taylor first. There was something I wanted to pull up.
It's up to Taylor. I mean, debate format would be you start. So Taylor, it's up to you.
No, that's fine. I'll do it. That's fine. Okay, hold on. Yeah, I just wanted to pull this up right quick because I'm not sure if you're going to ask this question from the audience, but I saw a question that I had a slide for, so I wanted to make sure I had that. Okay, so I guess for my closing statement, I want to say that there's a lot of built-in assumptions to this experiment. This specific experiment that we're looking at, there's a lot of built-in assumptions. He likes to say that there was no evolutionary assumptions built into it, but literally 1/3 of the paper is them telling us that evolution happened and then explaining how it could have happened. But the caveat is, at the end of this paper, it specifically says, although this happened in control environments, it will not happen in natural conditions. So we can see from the paper itself that he's using to prove this evolutionary process, they willingly admit that what they did in the lab will not reflect over into the real world. And that's what we're looking for. Why do things not evolve today? Why did they evolve in the past, but we can't see it today? Where are all these missing transitions? There was a great quote from that article that just made me laugh because it said, their transitions existed, but they're all extinct now. What a convenient answer, right? All of these transitionals, millions of transitional stages that had to exist, and they're all extinct except for the ones that don't show the transition. What are the odds of that? I mean, the statistics of that alone is ridiculous. Another point that I wanted to bring up is he constantly showed, oh, this is a new function, but it's not a new function. It's something that it could have done. He showed the list of the 5 new things that this cluster could do. Again, it's a cluster. I know he doesn't consider that as a valid argument, but it's a cluster. The new functions of it are not exactly new functions because it had all of the capabilities to do this in its genetic DNA or in its DNA gene pool beforehand. But what we do see is that now it's more dependent on others to survive. Even though he wants to say that the clusters are able to survive better for that specific environment, guess what? That environment doesn't exist in the wild. That's a controlled environment. Put that species that they created in the lab, put that in the wild and see what happens. More than likely, it's going to die off or it's going to revert back to its original form. The Chlamydomonas does absolutely fine by itself in the wild. It can survive polar conditions, desert conditions. It can survive the rainforest. It can survive in the ocean. It can survive in areas with no water at all. It can survive any condition it's put through. But now that they've manipulated it, I'm willing to bet that that cluster they made in the lab will not be able to survive all of those conditions. So this is not something getting better. Again, they're showing the opposite of evolution. They're showing that this thing will lose function and it will get worse over time. Again, this is the whole point that we're trying to make as creationists. When you look at the data, we see the opposite of evolution. We see things deteriorating. We see things devolving. We see things getting weaker and sicker and more diseases. Evolution needs to show us the opposite. Evolution needs to show us things getting better, stronger, healthier, more resilient, and they don't show any of that. So that's the final point that I'll make on this. The other point that I want to make is that I honestly don't care about these arguments. I don't care about who's right and who's wrong and who knows the most terminology and who can understand the most physical formulas. I don't care about all of that. What I care about is the fact that God created this universe. They want to reject God and they want to convince others to reject God. And that's the problem I have. If you want to believe evolution, fine, believe evolution, but stop trying to pull others away from their creator, because on Judgment Day, all of us are going to have to face God. And for those that you're pulling away from God, you're going to have to answer for that. And that's what I'm trying to save you from. I'm trying to save you from that judgment. So I'll go ahead and wrap it up with that.
Okay, Jamie, thank you for the 5-minute closing statement. We'll now hand it over to Snake. Whenever you're ready, floor is yours. 5 minutes.
All right. So your end statement is pretty telling. This is not about the science for you. This is about defending your religion. I say this every time. I don't use evolution to argue against God. I argue against God on moral grounds. I don't think evolution debunks gods. It debunks certain myths and interpretations of the Bible, but it does not debunk the idea of a creator. It shouldn't debunk the idea of a creator. You should not leave your religion just because if you're convinced of evolution. If your faith is that weak, then you should just abandon it now. But if I'm trying to deconvert you from a religion, I'm going to use completely different arguments. I'm going to use philosophical and moral arguments. Now, so I did not say that there are no evolutionary assumptions. It seems like you're not able to really remember anything that I've said. I literally said the opposite. I said that they make assumptions in this paper. All papers make assumptions based on the consensus of the field. They did assume evolution. What they're doing is testing how it works, and it does work. It evolved. It doesn't matter if it evolved in nature or it evolved in the lab. Creationists talk about how evolution is not possible genetically. So we give them papers like this, prove that it happened. So then they move the goalpost to, well, the conditions aren't realistic, even though it is possible and in fact did happen. So then we explain why these conditions are realistic to different times and places. And this is basically this rescue device, and I'll get to the other rescue device. These are ad hoc devices. They're not actually useful in any way. They're brought up only because the goalposts keep getting moved back and back and back. If these conditions are in fact plausible, and we can test this by looking at the rocks that show similarities. So there were not millions of different stages just for this transition, because it was done in a few steps. There are millions of transitional phases in the fossil record, predictable only by evolution, not by any other method, which makes it scientific. So, I mean, the question here, the central question is whether this cluster is a bunch of single cells working as individual cells, or if the cluster itself is acting as a single individual. I gave mathematical, quantifiable reasons why. I gave genetic reasons why it's acting as a single unit, because it's only reproducing in a specific genetic way that only multicellular individuals do. I showed that they are, and Jamie even admitted that they are cooperating and dependent upon one another. The other rescue device was that these aren't new functions, so therefore it can't be called cell differentiation. So it all hinges on whether or not these are new functions. I showed multiple times that these are new traits and functions, and so we moved the goalposts back to quibble about the definition of function. I brought up the definition of function. It meets the definition of function. These experiments meet the definition of every word that we've presented here tonight. So every time I would bring up data like this, the next engagement was him just ignoring that, and playing word games with intelligent input, even though we can virtually eliminate intelligent input. The only input is we're deciding what conditions we're studying, which are realistically plausible conditions. So that's about it, but I guess I'll go over again that these 5 functions here are new traits and new functions. Only these evolved clusters have bodies that are only clonal daughters. They are the only ones that have a permanent body. They function together cooperatively. The body is obligate. There's cell differentiation, which again is the cooperation part, and the unicellular bottleneck. These together and individually are meeting the definition of multicellularity.
Okay. Thank you, Taylor, for the 5-minute closing statement. And as expected, it was comprehensive. Excellent job to the both of you. We've had a very lively chat, lots of side debates going on, and therefore some solid questions for Jamie and Snake. So let's just get right into some of these questions. You both are not new to this channel, so as you know, whoever the question's for gets the last word, even a little back and forth on specific questions if you'd like to. But again, we'll allow the person who the question is for to have the last word. So here we go. Centurion 737, question for Taylor. What were the so-called predator that they used in the lab to force these cells to clump together? And are these predators found in nature outside the lab?
Yes, they are found in nature outside the lab. So it's a single-celled organism. Let me bring it up here. What was it? Could you repeat the full question again?
Yes. So it's up on screen here. It says from Centurion, what were the so-called predators that they used in the lab to force these cells to clump together? And are these predators found in nature outside the lab?
Yeah, I mean, I don't, unless they're like a created life form, they are not, they are found outside the lab. These are all living specimens are taken from the wild. And unless they're mutated or genetically engineered, they're called wild type. This was Paramecium tetra aurelia.
Okay,
And
Taylor,
so
thank
that's a
you.
single-celled predator.
All right, perfect. Jamie, any response, my good man?
Now, there's not really much to say on that one. I don't really do too much research on that paper in regards to the predator because, as Luca admitted in one of our debates, it doesn't necessarily support evolution because it doesn't fit the theory. There wouldn't have been predators at the time that they formed into the multicells. So I generally don't look into that paper.
That's a very strange claim because this is a unicellular predator. Cells frequently eat
Okay,
each
see, I
other.
wasn't aware of that. Okay, my apologies on that.
Yeah.
But he made the argument in our debate that, like, even though it showed them forming the clusters, that this doesn't necessarily prove evolution because it doesn't fit the timeline. Like something about the predator wouldn't have been present in the conditions they would expect. So, yeah,
I
he
can't
made some kind of claim like that.
I can't speak for him, but I don't think that that's true at all. There would have been, I mean, assuming that there were populations of unicellular organisms, some of them would potentially be predators, and there are fossils of even bacteria.
Yeah, so I'm gonna have to go look back at that debate then because it had something to do with the predator, I guess, but I don't know. I don't have too many details on that because I've been kind of focused on this paper and other things.
Yeah, cells can eat each other pretty easily. There's, in fact, that's the whole theory behind mitochondria, and there have been natural observations of this happening and laboratory observations of cells taking up other cells and using them as like an energy source or a different organelle. And there are some observations that have absolutely no human input at all of this, which is of
Okay,
course
we'll
predicted by evolution.
Okay, we'll give Snake the last word there since the question was for him. Okay, next question comes in from Taylor K. Thank you very much for the question. It is presented in two parts, so we'll work through it. Question for Snake. Single-celled bacteria are the most versatile and adaptable organisms on Earth. And according to evolution, were dominant for over 2 billion years. What evolutionary pressure appeared to make being multicellular advantageous?
Well, it wouldn't have happened in bacteria because, of course, bacteria never evolved past bacteria. It was other cells that became eukaryotes by what I just explained was by uptake of other cells. And that's pretty undeniable evidence of evolution itself because mitochondria in our cells have bacterial plasmid DNA, which is a completely separate DNA from our nuclear DNA and our chromosomes, which are not plasmid. So it's a completely different structure, a completely different location, different lineage, different type of organism. And it's in no way necessary because there are some organisms that have their mitochondrial DNA in their nucleus. So it's not a necessary feature. It's So it's not a design feature. But what evolutionary pressures appeared to push certain individuals, non-bacteria, to evolve. Well, we went over one of them was predation. Another one of them would simply be if it was advantageous somehow for you to be at the bottom of the pool of water or body of water versus at the top. And this is the question that these papers are trying to ask. What evolutionary pressures could have led to these changes? And these are two options.
Okay, thank you, Taylor, and thanks for the question, Taylor. So, Jamie, though, if you had a response, floor is yours.
Yeah, I actually kind of tried to get onto that topic earlier when I asked you what would have shifted to make this whole transition happen in the first place, and now we're in a Earth that's dominated by what we would consider less adaptive organisms. Humans are much more less adaptive than the Chlamydomonas or the bacteria. Pick your poison. Humans are much less adaptive than these things. So why are we the ones that are dominating the Earth? Just doesn't make sense. It seems like the Earth was created for us in a sense, as opposed to we evolved from something that was better than us.
Okay, so yeah, I feel like I didn't really address that first part of the question, which was like, so if they're so highly competent, why would they even need to change? Well, environments change, but it's also like the other thing is we can coexist with bacteria. Human beings are pretty adaptable, but we as multicellular organisms cannot just sit on the bottom of the ocean next to a magma flow and be fine. Stuff like that is pretty much not possible when you're getting into macroorganisms. There are advantages of being single cellular, such as being able to adapt to harsher environments because you're less complex. But it doesn't matter. So one of the things that has, people like to point out the difference between Darwinism and the modern synthesis. Well, we found out it's not just mutation and selection that leads to evolution. So a lot of the traits that we see are just like, okay, so what's the advantage of that? And a lot of these traits don't have an advantage. They're just there because they're piggybacking off of other traits or just by pure genetic drift. So populations will change no matter what. And if they're in an environment where that is favored, or if it just can coexist, then it will keep propagating. And so you don't even need the rest of your population to die out for your genes to spread. You can just spread your genes, and maybe in your neck of the woods, your population will change a little bit, but the rest of the populations won't change much, or they each change in their own ways. So just because you're adaptable already doesn't mean that you aren't going to gain mutations that are going to change your traits. It doesn't mean that you won't get into conditions that will need that your natural non-genetic plastic adaptation can take care of. That you might be in a condition that you can't adapt to just by the traits that you already have. You might have to evolve.
If you wanted to move on, I know you guys are having a little back and forth on that one, but let's move on right to the next question. Anyway,
he said something that I do want to ask him a question about. Ahead. He said, you said populations will evolve no matter what. So then why did all of these populations we see today stop evolving?
They didn't stop evolving. They're evolving now.
Oh, I guess we just can't see it, right? Okay.
Well, we do see it. It's very slow. Sometimes we can speed it up for purposes of studying. But there's no basis for saying they stopped evolving. Even things like coelacanth that are supposedly living fossils, you can compare them and see that the modern coelacanth is similar, but it's much different from the fossil coelacanths. Its skull has different proportions. Its bodies are shaped differently, etc.
Okay, well, we will move on to the next question. $5 super chat from one of your biggest fans here, Snake Bubblegum Gun. Appreciate the support and question. Question for Snake: is the man-o-war a multi-organism, organism? Not sure I fully understand that sentence. Because selection is acting on them as a collective by your definition, or organisms working together? ? Go ahead, Taylor.
Well, it's not really a jellyfish. I mean, I don't study Man of War, so I don't really know. It's supposedly, I mean, I can read Wikipedia for you, and give you my commentary. So yeah, I mean, I can come back to this if you want after looking at it, but it is different populations of it's a colonial organism. So yeah, I don't really have much commentary on it.
Okay, thank you, Taylor. Jamie, over to you if you had any thoughts.
So there's something he said that I thought was really interesting, and I'm going to use it in the future, Taylor, because I just really love that the way you said it. You said I can look it up and give you my commentary on it. You know, this is what I encourage everyone to do. I encourage everyone to look it up, read it for yourself, and then come to a conclusion. Like, critically think about what you're reading. Don't just immediately accept it as a fact because that's what they say in the abstract of the paper or whatever at the beginning of the textbook. You know, look into the details of these things. As far as Bubblegum's question, I'm not exactly sure what he's trying to get at with the Man of War. I try not to respond to Bubblegum too much either. So I'll just go ahead and close it there.
Okay, Jamie, thank you. Taylor, any final words?
Yeah, I mean, this would be an interesting one to look up. But it says all the zooids in a Man of War develop from the same single fertilized egg and are therefore genetically identical. They remain physiologically connected throughout life. Hence, the Portuguese Man of War constitutes a single individual, but is made up of individuals from an embryological perspective. So, yeah, I'll look more into that. I'm not sure what the difference there is right now. Colony are evolutionary derived from polyps or medusae.
All right, next question comes in from no worries. Okay, so we do got a question. So Snake's biggest fan was here. Very nice. And we also have Jamie's biggest fan. So crybaby question for Jamie. And I have a feeling CC's coming at you. The primary barrier to large cell clusters is a surface to interior volume. But don't multiple cells clumping together easily avoid this issue by forming a mat or strand?
I would have to do some research into that. I'm not too familiar with the process for what he's referring to. So yeah, I'll have to do some research into that.
Taylor, anything you'd like to add?
A mat or strand?
No.
Okay, next question comes in from Stephen Tibbetts. Question for Snake. If this ability was already in the gene code and the ones that clumped were specifically picked by intelligence, how is this evolving since information was lost, not gained?
The abilities were not already in the gene code. It's modification of abilities that were already in the gene code. The ones that clumped, they weren't picking ones that clumped necessarily. What they were doing, well, they actually were picking clumped ones, but among the clumped ones, there were some that evolved obligate clumping or clustering. So this would be a change in the genetic code. This would be a change in its developmental process. Some of them were clumping just because they can clump, but the way they clump is genetically and physiologically different from the ones that evolved. So it's evolving whether or not humans are involved. That it doesn't matter. The definition of evolution just is about gain of different functions through mutations and genetic drift, etc. How these are being selected doesn't really matter in the sense that it's still happening. We can argue about whether the conditions are realistic or not. But the second part of the question, how is this evolving since info is lost, not gained? Well, that's not even true at all, because some info, it's actually not losing information. It's losing functions, but it's also gaining other functions. So I'm not sure why some people just can't like hold two concepts in their mind at the same time. Evolution is about trade-offs. So you lose one function and you gain the other function. I gave those 5 functions that are gained by this organism. I'm not sure if this person asked the question before or after I drilled down on that, but I think Jamie even agreed to somewhat of that, even though we were disputing what an actual function is. So yeah, we can go over it again. I can list them all again. Maybe we can do that. Jamie, any response?
Go ahead, Jamie.
Yeah, so I don't think it's something that can be just dismissed, that this did involve intelligence to make these changes and in a controlled environment. But I won't focus on that. What I will focus on is the idea that even if there was info gained, right? Look, let's just, for the sake of argument, let's say that they gained a function, and now instead of doing it single-celled, everything by itself, it now works together to do the exact same thing that it did before. Okay, let's just go ahead and give them that, right? They got the function. How does this show the process of multicellularity moving up the stages to completely different individuals, like the human or the goat or the ostrich or whatever it is? You know, this is still an algae. It's an algae that is doing something that could be argued is still the same thing. Now, he's going to disagree that it's not the same thing, but it's still a valid argument that there is not really a new function being brought on here. So, of course, at the end of the day, we could go back and forth on that specific talking point, but at the end of the day, this still doesn't do anything for the theory of evolution, because it's not showing a drastic change that we need to see in order to get to the theory of evolution being a fact.
Taylor?
Okay, so it does not show human evolution. It's not even relevant to that. It's not even relevant to organ evolution, although maybe tangentially, because it shows the start of tissue differentiation, because it shows the start of, it shows cell differentiation, shows information and complexity can increase without genetic engineering, aka real intelligent design. We didn't choose what genes go into it. We only choose what survive, and even then, some of the experiments the predator chooses for us. This only shows the unicellular to multicellular transition. It's not really relevant to fish to human evolution. But yeah, intelligence, it doesn't matter. All that matters is the plausibility of the conditions that were selected. And I'm not sure if I heard right. If you said again that they do the exact same thing as they did before, well, all these traits that I have up are things that they didn't do before. And things that they do is a function, is an activity done by a thing, is the most basic definition of function.
Okay, let's move on to the next question. Comes in from Ray Giordano. Thank you for the super chat and the question. Nobody specific, but we'll read it and figure it out. Where did the Chlamydomonas DNA change? I assume they did a before and after, probably more directed at you, Snake. So we'll start with you.
Where did Chlamydomonas DNA change? What
I
does
think
he
he's looking
mean?
like a
Where
sequence,
does he
like a
want that?
sequence or something? Yeah,
Does he want the sequence?
that's what I think. That's what I think he's
It's
asking. Like,
well, I
is
showed
there a new piece of information in the DNA that they can trace? Like, I think that's what he's asking. Yeah, which is a good question.
So there's different ways they measured this. They sequenced them. Let me see here. So they did sequence them to see if they were genetically changing. Is my screen still sharing? Yeah. And the other thing that they did was look at the fact that this is not a response to the environment. It is obligate, so it is genetic. And they also looked at the same genes that are present in multicellular algae, which they have isolated the function of those genes, which is the altruistic function. So this was a genetic change to this gene in the unicellular Chlamydomonas, and changes that were predicted based on the Volvox model. We know the function of that Reg A gene. We know what it's doing. We know that it's an altruistic gene. And so they predicted, since the unicellular algae also have a similar gene, that mutations can happen to that gene, and it will have a similar function to the multicellular Volvox similar gene.
Okay, thank you, Taylor. Jamie, any thoughts?
No, we can move on.
Okay, next question comes in again from Ray Giordano. Thank you for the super chat. Question for either. Were epigenetic tests run on the Chlamydomonas DNA? Jamie, we'll start with you this time since Taylor went with the other.
Well, one thing I was thinking when he was talking about the changes in the DNA, it kind of was reminding me of the functions that we're discovering in ERVs and how, like, they're not active now, but they were triggered. I was wondering, like, I never really considered that aspect of things. Like, is that a possibility that what we're seeing the Chlamydomonas do in response to this controlled environment is we're seeing them activate something that has been, it's part of the design, but it just never was activated until now?
Okay, appreciate it. Taylor, any thoughts on that?
On the fact that it's a sleeper gene that was only activated till now.
Right, like what's to suggest that this could have never been a part of its functions at one point in time, since evolution is trading off things all the time?
There's no evidence to suggest that, and we do know what function that gene gives in the multicellular Volvox, and we know that the unicellular ones have this gene, and we know that they genetically changed.
Any thoughts, Jamie?
No. I just wanted to get what his response is on that.
Okay, here we go. A super chat from Sunflower. Appreciate the support there, Sunflower, and the question, and a very kind one for Snake Was Right. So, you're well versed on the topic and conventional theories for abiogenesis and evolution. Is there any aspect of that timeline that puzzles you?
No. Pretty simple.
All right, short and sweet. Okay, let's move right on to, I think we're actually going to get through all of the questions. So let's see if there's any we've missed. Creationist Crybaby, we asked his question. I don't think we did this one. Gabrielle Christian, thank you for the question. Question for Taylor. Is there evidence in the fossil record for the different transitional multi-cell types as they are purported to have evolved over time into more complex?
In the fossil record, I I'm not sure about that because it's really hard to get fossils of cells, individual cells. There's evidence in transitional. Is this only about transitional from uni to multicellular? Because there's fossils of like kelp, which is a multicellular algae. The main evidence for the transitional forms is just that there are so many different types of algae that exist today that exist along every point of the transitions. So let me see here. This kind of illustrates. These are all extant, but they're obviously derived from older organisms. So, and we can show that some of them can evolve into different formations, like what would be like the next step. So we know that there is a common ancestor between the multicellular Chlamydomonas and the unicellular Chlamydomonas in these experiments. And that kind of skips a few steps on this thing. So the evidence here would say, okay, so there are living organisms that can survive and function along different stages of what could be changes in evolution. So Chlamydomonas can evolve into gonium clusters. They can evolve into things that look like the Pandorina clusters. They can evolve into everything we see here except for the end Volvox, which has a more advanced organization of functional space because their reproductive cells are inside of the body in a specific location. They don't have a specific location in these experiments that we talked about today, which just makes the Volvox more complex. So the fact that there are organisms that can survive at different levels of complexity shows that there is evidence for evolutionary transition, because they're changing, and we know that they can change, and we know that they have changed. So it's like the evolution of the eye. If there are animals with like half an eye or parts of eyes, so you can show, okay, the basically it's a refutation of this idea of irreducible complexity. So you can build complexity through going through these different steps.
Thank you, Snake. Jamie, anything you'd like to add?
Yeah, so I won't get into all the assumptions that could have been built into that. But the one thing I would like to point out is we talked about this earlier. And I know that like this topic can get very technical. There's a lot of like technical things about this. But what's funny is that in some of the cases of these people that are like militant about like pushing this idea that creation is wrong and evolution's right, they always want to focus on the complicated and then completely ignore the obvious things that, we can see and understand without having to go through all these processes of learning everything. But the reason I bring this up is because we're talking about transitionals. And the theory of evolution says that between all of these transitions, there's thousands of different, maybe even millions of different transitions from one creature to another. And this is happening over millions of years. Ignore the idea of like where the layers are coming from and how they're getting fossilized. But with all the species in these millions of years, we still have zero solid transitional chains. We don't have chains. We have a piece here and a piece here and a piece here. And they're trying to connect these dots and make these assumptions based off of all these pieces everywhere. But we don't see any actual connection visibly in the fossil record. And just like this Chlamydomonas paper said, they literally were talking about that the reason we don't see these transitional forms, because you would definitely see these transitional forms because of how fast they can manipulate this in the lab. They say the reason we don't see these transitional forms is because they all went extinct before they fossilize. I mean, it's like, how convenient of a story is that? I mean, this is storytelling, not science. And that's why I say evolution is a belief, just like creation. We can put our assumptions on it, but we're not allowed to say it's science until it's fully proven.
Well, the individuals that I just showed would represent the transitional stages, but they represent that in morphology. But the fact that, there's genetic drift and other genetic changes that occur over millions of years, they're not exactly the same populations, but they have the same morphology as in the past. And that there are algae fossils. I couldn't name the species or anything for you. So these it's not that all the transitional forms are lost to time. It's that the transitional forms have evolved and are now extant in extant species, but they would have had similar forms as their fossil ancestors, which you can look up fossil algae. I can't name any of them off the top of my head.
All right, we've made our way through the audience Q&A. We have now
I was reading up a bit about the Man of War, so just for people who are wondering, so basically it's kind of a little bit more like an ant colony in that, so like jellyfish are a medusa, and that's the body plan. And it's born from a polyp, which is usually like fixed to a surface. So the Man of War is made up of different multicellular medusa and different multicellular polyps that are all attached to each other. So it makes it kind of like a fuzzy line. So that's why it's it's instead of a bunch of individual cells stuck together, it's kind of like a bunch of multicellular zooids stuck together. So yeah, biology doesn't like being classified is the lesson here.
All right, there we go. Leaving no stone unturned. We've got ourselves a 3-hour debate, although this is round 2. And so for anybody who wants to see round 1, please check the description box. Round 1 was a ton of fun. Round 2 was even more fun. And so great job to Jamie and Taylor for all the effort, all the time, work, and energy put into this debate. So to the audience, thank you for all the engagement. Some passionate side chat debates going on, that's for sure. It's origins debate, and that's good. Healthy debate. And so why don't we get some final words, final thoughts, though, from the debaters. We'll start with you, Jamie. Again, thank you for doing this. And final thoughts, final words?
Yeah, so for my final words, earlier I remember you said that for me, I don't care about science. All I care about is my religion, is what you said, I believe. And that's not true. I do care about science, but what bothers me is that there is things mixed into science that are not scientific, and they're being used to pull people away from considering other options. Okay, you're basically strangleholding people into saying that you have to believe evolution, or you're a conspiracy theorist, or you're a crazy creationist, or whatever it is. And it's like, I don't do that with my religion. Okay, I'm not saying you have to follow my religion, but I'm telling you what I believe is the truth, because that is why I do this. The reason I do this is because I truly feel that we will all face the judgment, and I don't hate anyone in this world enough to not tell them how to avoid that judgment. Okay, we are all going to stand guilty before God. And when we have to pay for our sins, there's an option of Jesus paying that sin for us. So that's why I go out here and promote all of this. And that's why I go and do these debates, is because at the end of the day, that's the important thing, is that I don't want you guys to force people into saying that if they don't believe your theory, then they are insane, or that, they're idiots, or whatever the word may be, conspiracy theorists, whatever. That's the problem. You can have your belief, you can put your interpretations on it, but as soon as you start calling it facts, now you're telling everyone else that they're wrong, and that's what's really wrong.
All right. Well,
Jamie?
yeah.
Yeah, go ahead, Taylor.
I guess I'll just respond to that. So, I mean, you guys are telling us we're wrong on the other side, so I think that's fair game. But what I think crosses the line a little bit is, definitely we're telling you you're wrong about the facts. Some people are saying idiot. Some people I would call an idiot, but I prefer not to bring that into polite discussions. But okay, so there's that, calling someone an idiot. But what you're telling us is we're going to be tortured forever and deserve it because we don't believe in your story. So I don't consider not believing your story a sin, just like I wouldn't consider you not believing evolution to be a sin. I wouldn't want you to be punished for not believing evolution. But yeah, but it seems like so those are kind of different standards there. I can't remember exactly what you said, but you said something about like I don't actually care about the data. Feel free to correct me on that, but my interpretation was
you said to me, you said that I don't care about the science. I just want to basically promote my religion. I don't care about science.
yeah.
Yeah, that's not true though. I do care about science.
I'm sure you do. What I was responding to was that you said something like, and I'm paraphrasing, like, I don't actually care about what the data says. What I care about is, the saving people's souls, stuff like that. So I'm not saying that you don't care about the data, full stop. It's just that you're saying that you have a higher priority.
No, what I was saying, I didn't say I didn't care about the data. What I was saying is I don't care about these debates. Like coming in here and like proving you wrong to be like, I'm the winner, I'm so smart. Like that's not my goal here. Okay. I will admit that I genuinely learn things when I go up against you because you challenge me. There's other people that I've done the debates with, and I'm not going to like call out names, but like there's no challenge to it. They're just reciting these talking points. You bring up things that actually make me want to go and study it. And because of you, I have a better knowledge of microbiology, right? So it's like, I love the science. I'm not trying to ignore the data, but what I'm saying is I don't care about winning these debates. I don't care about, having that title. That's not the focus of this.
Okay. Yeah. So it just seems like you have like a higher priority because you talk about how evolution is used to pull people away from religion. I don't think it is or should be. I think philosophical arguments should be done for that. Yeah. And we had a whole debate on whether evolution, well, it was evolution versus creation, but I made it kind of whether evolution is scientific or creation is scientific. That was last week, right? Check that out if you guys haven't already seen that. That was a team debate. That was pretty fun.
Oh yeah, you're talking about the modern day debate. Yeah. That was a good one for sure. And then we did the after show for a little bit. So yeah, that was a fun one.
That was a good like 5-hour stretch at least.
Yeah.
Well, gentlemen, we got a mini round 3 debate integrated here into the round 2 debate. So appreciate the final words, final thoughts. Lots of fun, very engaging. And I think it's a great idea to have these kinds of debates, these really hyper-specific debates. Zach Hancock in the chat was saying that these are some of his favorite debates, and I agree. And so we're going to be having a lot more of these coming up in the next month or two. I'll be doing a couple, one on the chromosome 2 fusion, one, I believe, probably on ERVs with Snake here. And so if you like the hyper-specific debates, stay tuned. We got a lot more of those coming your way. And if you like what you're hearing from tonight's debaters, Jamie and Taylor, Doki Doki Bible Club, I appreciate it, brother. There are the links so you can go check out their channels, hit that subscribe button. They're putting out some pretty cool content, or go to the description box and check that out as well. Next week we've got several debates. It'll be an entire week of debates, essentially. And so here's a couple. We got a solid mix. The Great Baptism Debate, Jeremiah Nortier and Gavin James. Is water baptism necessary for our justification before God? We've got a debate on the King James Bible. So Will Kinney and Caleb Percher. Are there any errors in the King James Bible? And looking forward to this one, dispensational salvation. So Pastor Anthony Aquino and David Preston. So if you're not yet subscribed, please make sure to hit that subscribe button. We're just a few away from 17,000 subscribers. So share around to your friends and your family, and also share around this debate, because critical thinking, these kinds of debates are important. So with that, Jamie, Taylor, thanks for doing this. Thanks for your time. To the audience, thank you for tuning in. And Standing for Truth is out. God bless all.